Welcome all, my name is Ermin, and I do have a habit of making these intro videos for pretty much all of my courses. So in these intro videos, I like to discuss the particular things about the course, some extra features that you get, and just things in general. Usually a pretty short video. I would advise you to watch it all the way to the end, even though I won't do any demonstrations here on how to use Bash and such things. This video is primarily intended to give you bearings on the course itself and to explain some additional features that will be available to you along with the course. So first of all, why should you learn Bash? What is it good for? Well, as a Linux user, rest assured that you will need to be familiar with the Linux command line. It is a necessity, and even though you can do most things with GUI, graphical user interfaces can be buggy, they can be problematic, they are far more vulnerable to exploitation. Plus, on top of that, if you have a server anywhere in the cloud, and any server that you manage out there in the cloud, if it's a Linux server, and most of them are Linux servers, you will need to do it via the command line, or at least via the web interface, but mostly via the command line, because nobody really wants to install a server with a graphical user interface. The reasons for this are numerous. First of all, it costs far more, as it takes a considerable amount of space on the disks, which of course you have to pay, and also the bandwidth is greater when managing these servers, because if you're running some sort of a remote desktop protocol or something like that, it's a very painful thing, especially because you need very fast connections for that to work. While on the other hand, if you're using SSH from the Linux terminal and are managing a server somewhere via the command line, you can basically do it in a 56 kilobits connection. It's not a big deal. It's going to work unless you need to upload or download some bigger files. Then you would need a bit of a faster connection, but the commands, the management itself will fly pretty much. And above all of that, just think of it in this fashion. All the power of the user rests here in the terminal. The terminal empowers the user. It enables you to do all sorts of great things, and you have a far wider variety of options as opposed to GUI. You actually have the control over things. You know what is going on. You actually see how certain things are done, as opposed to just clicking a button somewhere. So you learn nothing or very little by clicking that button while using GUI. While on the other hand, if you're using the terminal, you will learn a great deal about the operating system, about the programs that you use, about the programs that are running in the background, how things are kept together, how things function, etc. I'm not saying that the path ahead is easy, but Bash is definitely a lot easier to use for creating scripts, etc., than some other languages are. Basically, if you were to use Python, okay, Python is still very nice and convenient, but let's say you were to use C. I mean, it's a very powerful language. It's great. I personally love it, but it's kind of difficult, and the syntax is not very attuned to human mind, let's put it so. It's more attuned to the machine than it is to a human. While on the other hand, the syntax in Bash is very simple, fairly straightforward, easy to understand. There are some things which need to be explained in depth and so on, but it's not as hard to understand as some other languages are, some others can truly be a drag with all sorts of notations and such things, but Bash is not. Bash is fairly simple, straightforward, easy to learn, and you should be able to, after the completion of this course, to be able to handle Linux terminal and Bash without much difficulty. Even though there are some 2,000 commands in the Linux terminal, You, of course, will almost never need to know all 2000 commands. There is simply no need for it. But you will learn a good amount of them in this tutorial, probably more in these tutorials, probably more than you will ever need. But I like to leave it just in case to explain things. Anyway, in the videos below, you will see setup videos. You will find setup videos in the tutorials below. Actually, you will find setup videos that will show you how you can set up a Linux machine within Windows. There are multiple setups available. I have chosen to explain only a single setup. I have learned from the previous tutorials, when you give too many options, when you show your students in general, I don't know, how to create a dual boot, how to create a live boot off of a USB, how to do a virtual machine, etc. When you give all those options in one place, people tend to get confused a lot. So I decided to go with the simplest possible setup. I decided to show you how you can install a virtual machine of Linux on a Windows with ease, without any problems, and to use that particular setup. I'm running a Linux machine as my main desktop machine. I'm running Linux operating system as my main desktop machine, and I have been running it for, I don't know, at this point of time, I think it's been 8 years, something like that, and I've seen a lot of changes over that span of time. Anyway, in case something remains unclear, or if you want to ask about something, there's always the tech support in the discussion section. There are people who are paid who will provide answers to your questions, who are happy to do it. If you pose a question, somebody will be there and they will post a reply trying to help you out. When you ask for help, please do it. When you ask for help, basically try to describe your problem as much as you can immediately. So get the list of steps to reproduce your problem so that the person on the other side can reproduce the problem and solve it. I'm not saying this so that it is easier for us to do something so that we invest less effort or something like that. No, I'm saying this primarily because of you. Why? Well, because you will only wait for an answer longer if somebody needs to ask you additional questions, then you need to provide answers, and then somebody again needs to provide answers. So you're playing a back and forth game instead of just formulating the question the first time around in a proper way by actually specifying and stating how to reproduce a particular problem. If you can do it, it's fine. Just describe your problem the best you can, and somebody will be there to assist you in whatever manner they can. And we are happy to do it. So that's one of the things that you get with this course. There's a tech support in the discussion section, and we're always happy to help you out pretty much any way we can. This is the case with all of my courses. Now, next up, you also have a YouTube channel that you can visit. I will provide links in the description. And I generally like to place videos there that are solutions to certain problems which students encounter here on Udemy. So they find a problem within a course, and I don't know, the versions differ, their version differs of the operating system and mine, or the versions of the programs differ, something doesn't work. And then I like to upload videos to YouTube and post solutions there for my students from Udemy. So really there are some videos there that provide some nice solutions and instructions on, also amongst other things, on other setups. I mean, how to make a bootable USB dual boot, how to create a virtual machine on a Mac, etc. There are lots of useful videos there, so feel free to check it out. I mean, it's completely free. You don't need to register or anything like that. You can just go ahead and check it out if you like, or you can actually ask for some videos to solve certain problems, and I can post them there for you as well. I mean, again, completely free. There's no charge there. There's no registration or anything like that. You do not have to do any surveys or anything similar. It's completely free. You basically open up YouTube and watch the video. It's just like that. And the final thing that I would like to mention in this intro video is the fact that I am a human being. I am available. I'm just a regular guy. I am not like a lot of other people. When they have a lot of students, you cannot reach them. You can always reach me. You can always talk to me. You can always send me a private message. I might not respond straight away because I get a lot of them, but I will respond. And if I don't respond immediately, feel free to send me another message, because your message, I could have wanted to, I had an intent to answer you, but your message got lost. So if I didn't answer you, just send it to me again. Say, hey, you didn't answer me. Come on, what is up with that? And I will be happy to do it. I check my messages pretty much on a daily basis. So it doesn't matter what your question is. You can pretty much ask me, what is the weather going to be like in LA tomorrow? What I am going to do in that situation is go ahead and open up my browser and look at the weather forecast for LA for tomorrow, and I will give you a response and probably give you a link of reference where I got the information from. So I am reachable. I am somebody who is there for you if you need me. I'm happy to help you out. I even pay people to help you out in the discussion section. And plus, you can talk to me about pretty much whatever. Ask me questions. I'll be happy to answer all the private messages you send. You can even see me sometimes in the discussion section as well. Anyway, bid you all farewell, and I wish you a download of luck with this course. Welcome back all. So today I shall show you how you can set up a Linux virtual machine within Windows. Now there are multiple options available for setups. You can have dual boot, you can have a live USB that you plug into your machine, but dual boot with Windows 10 is kind of difficult. I mean, it can be problematic, let's put it like that. Ever since Windows 8 was implemented, dual booting with Linux has become increasingly more difficult. Anyway, if you want to check out the videos for dual boot, if you want to mess around with that, I've placed some on my YouTube channel, so you can have a look at them there. But here for this course, I figured we would just use a virtual machine and see how things work. Simple as that. If you also want to create a live USB, you will be able to find videos about that on my YouTube channel. It's completely free. You're not required to register or pay for anything. The videos are there. I primarily made them actually for Udemy students from my other courses. You can have a look if you want some other setups, but I'm going to show you this setup simply because it's the simplest one, nothing more. Anyway, so first of all, open up your favorite browser. And I am on my friend's computer here. I generally use Firefox and I don't use Windows, so I just came to my friend's house to actually record this part. And there are two things that you will need. So first of all, you will need your favorite Linux distribution. I am using Fedora, but there really is no reason why you wouldn't be able to use some other Linux distribution. You could use Ubuntu or whatever you want. Pretty much the same things should work more or less. And you will also need VirtualBox. That you will need to download. You will have the links in the description, so no worries there. You will need to download that as well. But before you go into downloads, go ahead and open up your system info on Windows. Basically, just go to this PC and then computer and then properties, and then this window in front of you will open. Now, first of all, take a look at which processor do you have. It says here Intel Core i5 6600K CPU. You do not require a CPU of this power for this particular course. You can pretty much work with very old processors. I personally have on my laptop, I think I have some sort of an i7 that goes way back. But that's not the point. This should work on pretty much any processor. However, virtualization might be problematic if your CPU does not support virtualization at all. If you're Intel or if you're an Intel user or an AMD user, you can go over to the Intel or AMD website and check the technical specifications of your processor. Like 99% of the time, it should work without any problems, and you shouldn't have to check this. Next important thing is to know how much available RAM do you have. So he has 16 gigs. Again, you won't need 16 gigs. You can get away with like 8 gigabytes of RAM on your machine, and for everything to be smooth and practical to go with no problems. Down below, this is quite important. It says system type 64-bit operating system. Now I will go ahead and download VirtualBox now from the download link. And it says here VirtualBox 5012 for Windows hosts. So just go ahead and download the first one. If your machine is 32-bit, it should by default offer you the one for 32-bit as well. That is how it works on the Fedora website. You just go over to the Fedora and then you click on Workstation. Actually, you can just click on Download Now. Download Fedora 23 Workstation. Sure, why not? And it says it should begin in a few seconds. If not, just click the link down below. So if it doesn't actually begin, just click the link. No big deal there. So the internet connection here is, I would say, relatively fast. It's not the fastest. It doesn't have the fastest of internet connections. So the download time is actually 4 minutes, which is a bit painful. The file is not that big. It's 1.4 gigabyte. So it should download fairly fast. But as I said, there's no reason why you cannot use some other distribution, although I will be using Fedora and I will be doing the demos in Fedora itself. Also, I am using a VirtualBox. If you want to use VMware or some other hypervisor, you are by all means free to do so. There is no reason why it shouldn't work. You just need to know how to configure it. That is all. But I know from previous courses that a lot of people on Udemy are using VMware or Parallels or something like that. So completely irrelevant. Just go ahead and download VirtualBox without any problems, or VMware or Parallels or whatever other you want. Key thing to note is that you should never have more than one hypervisor on your machine. Either have VirtualBox or VMware or something else. Whatever you install, make sure to uninstall the other one before you install the new one. Be very careful about that, as that can lead to a lot of problems. Also, if there are any Mac users out there, if you just send me a request or something like that in the discussion section, or just if you send me a PM to create a setup video for Mac, I can do that as well. But if you don't want to bother, you can just check out my YouTube videos. There will be a section on how to set up a VirtualBox on a Mac and how to install Linux there within a VirtualBox, so you can see it there as well. But if there are enough requests, I can post instruction videos for Mac users as well. Although there is nothing really that different. You basically just install VirtualBox on a Mac the same way you would install any other software. You can see here it says VirtualBox 5012 for OS X hosts. And then you download Fedora, and the process from that point on is pretty much the same. There are no significant differences in my opinion anyway. I've done the installation on both systems. I generally don't use Mac. I've bought a MacBook Pro from 2011 so that I could better help people on Udemy who are using Mac, so that I can understand their problems and see how it actually works. My experience with the OS X is somewhat limited, but I generally didn't really enjoy it that much. Anyway, I don't have anything against it. It's a pretty good operating system. But also, in terms of Bash, you should be able to do most of the things that I'm doing in Linux within the Mac terminal as well, because most of the things in this course will be done in the terminal, if not all of them. So you can just pretty much do the same things on a Mac, open up a terminal, and write Bash scripts there. Most of the things should work, although no guarantees there. The download should finish in about 20 seconds, so that should be fine. I know I should have downloaded this sooner. Anyway, let's go ahead and begin the installation of VirtualBox. Okay, always asked before, run. Next. Sure, why not? Next, process, yes. It will reset your internet connection in all likelihood, but it shouldn't affect the download too much. Install, yes. The installation process is fairly fast and straightforward. Now just go ahead and install this, because you might need it at some point of time. Okay, sure, start it afterwards. And there we have it. So we have VirtualBox here. It's up and running, no big deal, fully functional without any problems of whatsoever. Now you're gonna go ahead and click on New, and if you are using Fedora or if you're using Ubuntu, well, simply just type the name of the operating system, or name your system whatever you like, in fact, just whatever you like. Here, I shall name this Fedora. Oops, Fedora. I hate his keyboard, but it's okay. It says here Linux, so select Linux, and down here it says 64-bit because this is a 64-bit system. I'm going to select 64-bit. Now, keynote here. Good amount of you, well, maybe not good amount, but let's say that maybe 10 to 15% of the people will not have virtualization enabled in BIOS, and that might affect you in a sense that you will only have 32-bit options. In that case, you have two things that you can do. You can either go to BIOS and enable virtualization, or you can go to the Fedora website and actually download the 32-bit version. Here, I do believe that it's here somewhere. It should be Fedora Spins. Yep, there we go. Fedora Spins. And I don't know where it is. This is unless downloading. It should be around here somewhere. You know what? Forget it. Let's just type in Fedora download 32-bit. By the way, only download from the official website. Don't go like God knows where downloading. So only from the official website. Don't go to some other places. Okay, fine. Let's go into the workstation. It should be here. Please tell me that it is here. Why are you not giving me the option to actually go for the 32-bit? Is beyond me. Come on, get Fedora workstation. There we go. So it says other downloads, and it's 32-bit image. It's a little bit smaller, but I mean, you're not going to be deprived in any way if you download a 32-bit image and use a 32-bit system. For what we're going to do in this tutorial, it literally will not make a difference to you. So if I just go to Fedora, I want to show you the path once again, even though I'll leave the link. So you just go to Fedora, download now, and instead of clicking this default download button, you just select the 32-bit image if you only have the 32-bit options here, even though your system is 64-bit. Or, if you like, you can go into your own BIOS and enable virtualization. Just look for something to do with virtualization. So on some motherboards, it is disabled by default due to some precautionary measures. Anyway, just go ahead and click on Next. Assign the amount of RAM. I would suggest assigning at least 3 gigs, but you can get away with less than 2. So no big deal. You can get away with less than 2. The system should run just fine and smooth without any problems. So go ahead and click on Next. But if you can spare the 3 gigabytes, it's always nice because it makes your virtual machine run a little bit smoother. But 3 gigabytes, let's understand one another, is an overkill. Seriously, for this. You can get away with far less. Anyway, create a virtual hard disk now. Yes, please. Just go ahead and click on Next. Next, and what should be the size of your virtual disk? Now, please do not go below 30 gigabytes. 30 gigabytes is the bare minimum, in my opinion anyway. Anything below, you might have some problems, you might not, but I would suggest to go with 30 gigabytes just to be on the safe side. So make sure to change this and to set it at 30 gigabytes, and make sure that you actually have 30 gigabytes of free space on your drives, as you can see here. Create. Excellent. So now this is done. Just go ahead and right click on it, go into settings, storage, where it says empty, click on it, click on this disk, choose a virtual optical disk file, go into downloads, Fedora Live Workstation, click on it, click on open, OK, and then just power the machine on. So, yep, there we go, the machine is powering on. Start Fedora Live. You basically begin the installation by actually starting the live version, running the live version, and then beginning the installation from the live version. Sorry. Anyway, I shall go ahead and wait until the machine boots. Keep in mind also that you won't have a full screen immediately. It will be like this, and later on we will convert it into a full screen. So let's go ahead and click on install to hard drive, but actually wait. Go ahead and click on the devices, network settings. For the time being, make sure that it's in NAT mode and that you are connected to the internet. So make sure that you are connected to the internet. And then check the virtual machine. It says PCI Ethernet connected. Okay, good. Now go ahead and click to install to hard drive. Just make sure that you are connected. The VM is connected and that your host machine is actually connected as well. So just go ahead and choose the language that you wish. No, I don't need R, I need E. There we go. And I need N, and it's English. States. Okay, so just go ahead and click on, actually, I'm gonna select UK for myself, but you can select whatever you wish. Go ahead and continue. Okay, so keyboard UK, time, date, and network and host name. It says connected, so that needs to say connected there. If it's not connected, the installation will still run fine, but I would suggest that it is. Just click on done here, so you open it and then you click on done. You click on installation destination and you just click on done, because you only have one virtual hard disk anyway. It should not touch it shouldn't touch the rest of your file system. And go ahead and click begin installation. So root password, go ahead and set the root password here. If you type in a weak password, it will demand that you click done twice. I would suggest that you put something appropriate. And then the user creation. Please do not forget your root password and do not forget your user password. That's like quite important. So let's go ahead and type in the username. You can type in the full name if you like. That's just, I'm just gonna type nonsense here. Like, it's just gonna be test. But just type in your own username and type in your own password. That's really all you need to do. Go ahead and click on done. You need to click on done twice again if the password is weak. Anyway, I shall leave you here and wait for the installation to finish, and then I shall come back to do the rest of the work. Welcome back. So let's just go ahead and click on quit here. Actually, that's it. Just reboot the machine. So just restart. It's taking perhaps a little bit fast. It's a little bit faster here because I'm on an SSD. Might be a little bit slower if it's an HDD, but really, I mean, for what we're going to be doing, it's not a big deal really. You won't even feel the difference. Okay, so yeah, you might feel it during the boot time though, of the VM. And I am of course a genius who has forgotten to actually eject the CD. So power off, and right click here, settings, storage, Fedora Live Workstation, remove. Yep, there we go. You can always add another one. You see, just click on plus and click on leave empty, so you'll get an empty one. No big deal. Okay, now power the machine back on. And there you go. So just press enter. It's powering, it's powering. Just give it time. There we go. So just log in. wait for it. Just needs to do its thing. Once it's done, there we go. Ah, wait, you gotta finish this initial setup, so just go ahead and select English, click on Next. Basically, next, if you want to allow some applications which you install to determine the geographical location, basically, if you want to allow that, feel free. I generally don't have a need for it. Maybe if you're using some maps or something like that, it can be nice. And automatic problem reporting, it's not a bad thing to leave this on. It sends genuinely anonymous reports to Fedora if there is like if an error occurs. It should be anonymous anyway. Basically, it says sending reports of technical problems help us to improve Fedora. Reports are sent anonymously and are scrubbed of personal data. Since Fedora is completely open sourced, they're really not hiding anything here. It's not a bad idea to help them out in this way, but you don't have to. You can disable it. It's not like a prerequisite or anything like that. It's a completely personal choice. And we're not gonna attach any accounts. Start using Fedora. And we're not gonna need this. Just close it. But look here. If I expand this like this, it doesn't give me the full screen. So what we need to do is basically go into Devices, click on Insert Guest Editions image, open up well, actually, you don't need to, because this is popping, but I purely doubt it will work. Just click on Run, provide the administrator password, that is the root password which you have configured. Click on Authenticate, and wait for it. It should run just fine. As long as it gives us the full screen, it should be fine. This is the main guest editions failed, but as long as the graphical things work out, that's going to be enough and sufficient. Because the only reason we're installing guest editions now is to get a full screen. This can be fixed, that the main guest editions module failed, but as long as the full screen really works, that's all that we really need. I didn't want to complicate it any further to introduce anything complex. Basically taught by previous experiences. Okay, you see that even if I minimize and expand this, if I contract and expand the screen, same thing. Well, that's because I need to restart the machine. So just go ahead and restart the machine. And some of you might be wondering, oh well, why aren't you going into greater detail, etc. Well, I did in all my previous courses and explained like a lot of other setups. For example, in the ethical hacking course, there are like 4 or 5 possible setups, but most of the people just found it confusing. So I figured I would stick to the basic setups here on Udemy so that they would follow a certain stream. And if somebody really wants some other setups, you can find them for free and of any registration on the YouTube channel. Okay, so it looks like we'll actually need to conduct this fix. So let's go ahead and see how should we fix it. Why am I showing you how to fix it? Well, you see, the problem has not been resolved. We still have the smaller screen, and I was hoping that at least the window would work, that the full screen window would work out of the first attempt. But unfortunately, it won't. So we will actually need to troubleshoot. It's not that complicated. I'll show you in a moment how to do it. Okay, so just go ahead and click on Activities. Type in Terminal right here. Type in SU, press Enter, and then type in the root password. There you go. During your typing of the root password, it's not going to display anything, but it's being typed in, trust me. Clear the screen by pressing Ctrl L, and I had a set of commands for you here. So okay, you first need to type in dnf install kernel-dev, and then this thing here with the numbers, that's the version, etc. But if this is not the version you need, you can type in uname-r and confirm that that is indeed the version you need. So I installed this one prior to me doing the updates, so you see that the versions do not match, and therefore they will not match with you. What do you need to do? Well, first off, just delete this, leave kernel devel, and instead of install, type in search. Press enter. And there you go. So basically you have it listed here. Just go ahead and install it. That's really all you need to do. If there is some other version or something like that, feel free to do that. If it's newer or if it matches your kernel, if it matches the output of uname, install, and that's literally all you need to do. So with me, it's already installed, therefore there is nothing to do. But you'd also need to type in dnf install dkms. Again, nothing to do, it's already installed. I paused the video and then I installed these things because I know it takes a while for them to install. You'll see it will take a while for you as well. And after these two, basically just type in dnf update, press enter, and the update might take a good amount of time. After that is done, go type in cd run media, your username, and VBox additions. If you're wondering how I'm typing so fast, I'm not. I'm just pressing tab and it's on autocomplete. And then go ahead and run VBox Linux additions.run. Press enter and wait for it to finish. It shouldn't take too long. It should be relatively fast. And afterwards you will be required to reboot the machine. So keep that in mind. Basically two things you need to install and an update that you need to do in order for the screen to be able to, in order for you to be able to spread the window onto the full screen to get the full screen image. So this time we have all OKs and no fails, none that I can see anyway. It might be missing something, but I don't know. It really is not important. All we really want is bash, to be honest. Now type in reboot and press enter. Wait for it. There we go. Booting and booting and booting. Let's log in. And by the way, another reason why you should install guest additions is to get a bit of performance boost. So just go ahead and expand it onto the full screen, and there you go. Now it is spread across the entire screen. You can even go into full screen mode here in view and then switch from here. So it will seem like that's the only machine except for this bar down here in the bottom center. I'm just gonna exit this and exit the full screen mode. Don't really need it. Now you can also, there's nothing wrong with pressing this X button and just stating power off the machine. You can also save the machine state, but it's not that reliable as it can malfunction and then you won't be able to bring back the saved state, but you will need to power off the machine again anyway. So best thing to do is simply to, out of these three options, to power off the machine. Okay, that's the recording software that you saw there. It just came with the graphics card that he has in this machine, so that's nice. I'm not sure actually which one. Anyway, if you just right click on your machine and go into settings, and then you go into system. So on the in the motherboard section, you actually have the option to increase or decrease the amount of RAM. These options can only be changed while the machine is actually powered off. You cannot change these options while the machine is powered on. So you can increase or decrease the amount of RAM here. Next up, you can go into processor, and if you get an error, it's require Pi or NX, then you can just go ahead and come here and enable them. Next up, you can assign the amount of processor cores you would like this machine to have. If you assign too many, you will find a statement down below. It will say invalid settings detected, because you cannot assign all 8 processor cores because, hey, this machine needs to use some others. Well, basically these are threads. These are virtual cores, as
the machine itself has an Intel processor, so there's hyper-threading involved. And you can see I can actually only assign 4 cores. I don't really need to. If you want your machine to run smoother and you can afford it in terms of processor time, in terms of processor cores actually, you can assign more than 1 core. You can go for 2 cores. 2 cores is not a bad option if you can afford it, that is. If you don't have a dual core processor, if you have a quad core processor, you can assign 2 cores. It should increase the performance of your virtual machine. It will just make it a bit smoother to use and a generally more pleasant experience, but there is nothing wrong with leaving it at a single core, nothing wrong with that at all. Acceleration, this you do not need. But it says here hardware virtualization, and I have enable VT-X and AMD-V. So these are the 2 flags that the processor must possess. If it's Intel, it needs to have VT-X. If it's AMD, then it needs to have AMD-V in order for it to be capable of hardware virtualization. So just see which processor you have and check with the manufacturer to see if these 2 options are existent. Although VirtualBox can run on systems without the enabled hardware virtualization, but you can encounter so many problems. Even though most of the newer ones, they have these options, and even not so new ones, they have these options. As I said on my laptop, I have a processor from 2008 or 2009. Everything runs buttery smooth, pretty much. Okay, so just go ahead and click on OK, and that would be it as far as the setup is concerned. Now look, just because I am doing this on a machine that actually has a Skylake processor inside, it is completely irrelevant. Trust me, you do not need that processor for this purpose. It's good for some other things, but it's a complete overkill for this purpose. You can run this on a pretty old processor and it should still work as long as it has those specified options that I've just stated. In any case, I bid you all farewell, and I wish you a successful setup, and I hope that we shall have a good time going through this course together.
Welcome back all. So this will be our first tutorial where we will actually deal with Bash. So there are a few more aesthetic things that you can do to make your screen look better. For example, I have changed my background. Right click, change background. Oops, it went onto my other screen. And then you can change the background of your desktop and of your lock screen as well. So you see, you just click on it and then select from it. So you have, I don't know, some wallpapers. You can, so you just add pictures to the folder and they will show up here. Basically, here is the folder. This is the file manager. You open it up and everything is going to my other primary screen. So you have documents, downloads, music, pictures. You can put it here in the pictures and it will show up there, the ones that you download from the net. Also have my USB down here. It's named Fedora Live. I forgot to relabel it. I'm not running a live version. Let's close it. Also, since we are using GNOME desktop, you can just use your mouse and hit the upper left corner once, and you can see you get this menu. Now you can get here by pressing the home button, basically the one with the Windows screen, with the Windows icon on it. So you just start button, however you wish to call it. You just press it and this happens. So you get into it, or you just hit the upper left corner. Now, I have customized this bar on the left side to a certain extent with some of the tools that I like to use and that I need. For example, I have Kdenlive, which I use for video rendering and editing. Here is the file manager, which will be here by default, the terminal, Firefox, web browser. I have boxes for virtualization here as well. Decided to give it a try to see how it goes. Thus far, pretty good. System settings, etc. Now, up here is the search bar where you type in the name of whatever you wish. For example, terminal, and there you go. You have the terminal here. So you can just go ahead and click on it and it will open like everything else. It opens up on my other screen, but okay, never mind. I'm just going to go ahead and open up another one. So you see, once you attach it here, you can open it here. To attach it, just drag the icon and put it here. It will be placed there. doesn't want to go there now because it's already there, but like this. And if I was to release it, it would be there, no problems. To exit this screen, just press the start button again or hit the upper left corner again, no big deal. And you will be back. I have also changed the host name of my machine because, I don't know, I like to have my own name that I tend to use. If you want to use it, if you want to change it yourselves, okay, let me just drag the root terminal, another one here. You need to become root. So you become root by typing in su, and then you will be prompted for a password. I'm not prompted for a password because I'm already root, so you just type in su, type in the password, and you will become root. Then you can use this command to temporarily change your host name. Where is it? Give me the long version, please. Oh man, it's bound to be somewhere here. Never mind, I think I have it. There we go. So like this, hostname ctl set dash hostname space dash dash static. I pasted the command basically because I didn't want to retype the whole command now. And then you type it in like this, quotation mark, something. Press enter, and your machine from that point on will be called something. Of course, you will put your own name there, the name of your own choosing, that is. Okay, so we will need the root terminal for a few other things. Before we get into the terminal, let me just show you how you can customize it a little bit, because we all like to do that. Go into Edit, Profile Preferences, and then you can mess around with the terminal. You can state your cursor shape. You can use the font. I'm using font 16 because I want you all to be able to see what it is that I'm writing on the screen quite clearly. I could go a bit further, maybe 18 or something like that. Yep, let's leave it at 18, no big deal. Just so that you can see it better, but use whatever font suits you. And then you have certain commands which can be run, but that's not really interesting to you now. You can use the system colors, or you can use your own colors. There are built-in schemes. I'm going to use white on black. You can use whatever you wish, or you can customize it yourself. You can select the text color, the background color, bold color, etc. And you can also have either a transparent or a non-transparent background. So whatever you wish, it's up to you. You can set the amount of transparency that you will have, opacity as it is called, so you can mess around with it there. I do believe that's about it. So no need to actually change anything else here. If you want, feel free to mess around with it further. I just figured that this setup would do you the most good. Now, we're gonna need two terminals, so yeah, but later. First of all, we need to use DNF space update. And I've just done this in order to save some time, but for you, the update will take a while because it will pick up a lot of updates for the system. You don't need to reboot the system at this point of time. It is not like Windows. It is very different from Windows. It does not consume time upon shutting down the machine where it says, please don't shut off your machine now. And it does not consume time when you're booting up the machine where it says configuring the updates or something like that. No, there is no such thing here. What you do during the runtime will be applied, and once you boot the machine next time up, it'll go just fine without any problems of whatsoever. You will suffer no delays. Now that we have done that, please type in DNF install vim. It's already installed here. During the installation, you'll be prompted one question. You can answer it with yes by typing in Y. It's going to ask you whether you wish to install it or not. So just press yes to install it, or N, no, don't install it. You need to be connected to the internet in order to do this. You can view the status of your connection in the upper right corner. You see there's one Ethernet card and the other one, and my wireless is turned off completely. So you can just check it out here, and you can have wired settings. So feel free to mess around with it. You see it's on. it will be on by default, so you won't need to actually do much here at all. If you have any problems, if you need any help, the discussion section is always there for you, so feel free to come around and I will be more than happy to help you out any way I can, or the staff will be there to help you out as well. Anyway, now that we have done that, let's go ahead and clear the screen and move. We're no longer going to need the root terminal at all. So let's just exit. And we're going to need two terminals. One is going to be up like this. It's going to consume most of the upper portion of the screen. And the other one is going to be down. You don't need to position them so. You can position them any way you like. I personally like it this way because, well, you'll see soon enough. Better to demonstrate than to actually talk than to give you some dry talk. Let's go ahead and exit our root. There we go. Clear. To clear the screen, you can press Control L, so you can have a command, some command, and some command again. And then while the command is written, you can press Control L to clear the screen and the command will stay there. It won't be hindered. Or you can just type in clear to clear the screen, which is very useful and it comes quite in handy. Now that we have these basic things set up and running and going, if you have any questions about setup, additional customization, if you want to do something but don't know how to do it, feel free to ask. But this is what you need in order to be able to learn Bash. So you don't need pretty much anything else. This is more than sufficient. If you don't like transparency, well, don't use it. I prefer it. I think you have a good contrast and that you'll be able to see everything. Anyway, the first subject of today will be unique or special characters. Now, these unique or special characters you will need to know, and it will help you to read the code. It will help you to understand the code. I will begin with them, and then we will go over a series of other things which will enable you to understand the code. Once you understand the code to a certain extent, we will move on into scripts, and these scripts will increase in size. Some of them will be shorter, some of them will be really long, and hopefully through practical examples and through practical usage, you will be able to learn Bash scripting. So let's begin. These unique characters or special characters, they are a part of Bash scripting language. These characters, they have special built-in meaning in Bash, just like Bash commands do. So for example, one of the commands would be that we've just used, clear, to clear the screen. So clear, this is a Bash command. It's going to clear the screen. You can also put it in a Bash script, or you can type it here in the terminal. In Bash, you can group sets of commands, which is quite in handy because you don't want to be. It's quite in handy for repetitive tasks, so you don't have to retype them every time you want to do it, but run one script, and one script runs 100 commands, which is very nice. So the very first character that I plan to talk about today is hash. So this is hash, and it does have a considerable amount of functions in Bash. So there are certain things that it does. One of the most common things that it does is denote comments, denote comment lines. But aside from the comment lines, it's also you can also use it to tell the machine how you would like the machine to interpret the shell that you have written. Here's what I mean. If we type in VIM is a text editor, and if we want to open up a file and create a file, you can open up existing files, but if the file doesn't exist, the file will be created. So let's name it first. Let's name this file first, and let's put the extension .sh. Press enter, and now I will go ahead and start typing things in. First of all, VIM is not that simple. It can be quite complex at times, but very powerful. You will learn it and you will get used to it. Don't worry about it. If you don't get it immediately, it's fine. I will tell you all the things that you need to know along the merry way. So it has multiple modes. they're very useful because if you open up certain files, you don't want to be able to immediately edit them and make errors there. You want to be able to open them, have a look at them, and if you want to edit them, then you switch to another mode because you don't want to accidentally edit something. So in order to exit this mode and enter insert mode, you just press I. And now you are in the insert mode, and you can see at the bottom it says insert. Now you can type things in. To exit insert mode, you press escape, and there we go. You are outside of the insert mode. You can no longer type things in. So let's go into the insert mode again with I, and let's type in hash exclamation mark slash bin slash bash. So you can see now that I am telling the system with this statement, please interpret this script as a bash script. This is a bash script. So that's what I'm telling to the system. And this is only valid if you put it like this. You could have told the system to interpret it as a Python or a Perl script or something like that. Doesn't matter. For the time being, we're using bash, and that is what I want to teach you here. Perhaps later I can create some additional tutorials for those scripting languages as well. Now if you press enter again, we are creating this is the template for our first bash file. If you press enter again and you scroll down a little bit, now the next command that we will use will help you understand what comments are. If we type in echo, echo basically just prints out to the screen whatever it is that you type in. So it just repeats. Look, hi there, how is it going? What sort of a day are you having? Okay, the contrast is getting pretty bad. Let me just be quick about it. Preferences. Profile preferences. Let's kill the transparency. Okay, I was really hoping that the contrast would be better, but no. You can see things better like this. Anyway, it says hi. Hi there, how is it going? What sort of a day are you having? Any good? And quotation marks. Now this will be printed out to the screen. And if we would like to create a comment, for example, explaining what this command does, obviously you don't need an explanation of what echo does, but sometimes you have certain complex functions which you need to explain because somebody else will come and use that code and read that code and they won't have a clue what it is that you were talking about. So they need that comment, and from that comment they will read and know what the function does. Comments are completely ignored by the system. They are not taken into consideration by the machine, and they do not affect the execution of the code. So for example, I can type in hash here and then state this will print whatever through the screen. Excellent. So there you go. And if you don't believe me that this won't be executed by the system, take a look at what I'll do next. I'll state echo, and I'll do something. I'll say, do you see this? Close quotation marks. And this will not be printed out to the screen. This will just be a comment. You will not see it anywhere other than inside the code itself. And one more thing. How many of you believe that I have actually went into the next line with is? I haven't. Let me just relieve your doubts. Until I press enter, and until all the way, if I'm just continuing to type here, this is all considered to be a single line. But if when I press enter, you can see that the highlighting changes completely. So I am in a different line now. And if I type in echo, the different line, you will see that this will indeed be printed out. And that regardless of whether or not this actually seems like it's in the next line, it's not. This is all considered to be a single line. How do we save the contents here? Well, you write the contents out to the file. So you press escape to exit insert mode, you press colon, and then you issue commands, text-based commands. For example, you type in W to write things, and then you press Q to quit. Then you can press exclamation mark to force this to happen. There's no need to force it now. But for example, if you have conducted changes to the file and you haven't saved them, it won't allow you to quit unless you force it or unless you actually write them. So if we wanted to quit without saving, we would type in Q exclamation mark. But if we want to quit with saving, you would write WQ. Press enter, and there you go. We are out of the file. Now we would like to execute this file, run it, and see what happens. So if we type in ./first.sh, press enter, it says permission denied. What could this be? Why is the permission denied? Well, let's have a look. We use the ls command to list the contents of a certain directory, and we use ls-l to get a long listing. And if we get a long listing for first.sh, we can see the permission sets. So these here are permission sets. What I have selected are the permission sets. So read, write, RW, read, write, and X is for execute. You can see that nobody has execute permissions. The first three are the permissions of the user. The second three are the permissions of the group to which the user belongs. And the last three are the world permissions, the sort of permissions that everybody has for that particular file. So we need to give it execute permissions. How do we give it execute permissions? We type in chmod +x first.sh. And now we can run first.sh. And you can see it says, hi there, how is it going? What sort of day are you having? Any good? And then it says different line here. The comment has not been outputted to the screen and you cannot see it anywhere. It is not like in Windows where you have .exe file and it will execute everything. No. You need to have a permission regardless of whether it's an executable script or not. You need to have a permission. Anyway, as I am running a bit short on time, I bid you farewell, and we're gonna go, and I hope that I shall see you in the follow-up tutorial. Okay, so let's continue with the demonstration of hash. Reopen the file the way I have opened it up in the first tutorial. Hopefully you know how to do that by now. In case you don't, let me just go ahead and show you real quick. vim first.sh, it's open. Now, go ahead and delete everything in it as I have. You need to be in insert mode and press backspace, and you will just keep on deleting until everything is gone except for the very first line. Re-enter insert mode, and let's continue. So, if you type in hash like this, echo, quotation marks, tra-la-la-la-la-la, hash hash, or just hash, and then type in blah blah blah. Do you believe that this is a commented line? Will the program take this into consideration? You have until I can run the file to figure it out, or just pause it. Yes, it definitely will take it into consideration. This is not a comment line, so keep that in mind. But for example, if I had something like this, insert. If I didn't have these quotation marks, and do you believe that this is a comment now? Well, yes. See? Tra-la-la-la, but blah blah blah, it remains a comment. Simple enough to understand. Now our next example can be by using hash in order to get certain values out of variables. So let's put it like this. There's a textbook example, again with echo. I will type in name, which will be some sort of a variable, and I will state that variable to be equal to t. I know that I will explain some things. I need to use some more complex things, some more advanced subjects in order to be able to demonstrate the meaning of these simple ones. So don't worry if I don't explain something straight away. As long as you understand for the time being what special characters are, how they actually look like, yes, and what are their functions and how can they be used, that's good enough. You don't need to understand everything else that I've done on the screen, because I will explain it in the follow-up tutorials. I will deal with it throughout the course, so don't worry about it. It's just that I have to use certain things in order to be able to demonstrate how special characters work. That is all that there is to it. So I have assigned the value t to the variable name, and now I shall echo out the word not t, name, which is a variable. It's a string which contains the value of t, and I'm using a $sign to print it out here. So the word contains, and now we're going to use a $sign again. We'll use curly brackets, and then we'll use hash name, closed curly bracket, chars. This will effectively give me the number of characters of the word or the string t. Let's have a look. The word t contains 3 chars. Notice that $sign name has been replaced with its value, so t, and the number 3 has replaced this statement here. So this is not a comment. This is a certain value. You're extracting something. Okay then. That's done. We can just leave it as is. No need to delete it. We can delete it before the next one. Let's just see another one where hash is actually used to convert numbers from one number system to another. So if we're going to use a $sign again. Open the parentheses and then type in 2 hash, I don't know, 111, and then close the parentheses twice again. So this is a binary representation of number 7. We will use this expression, and you see where the hash is. So this is not a comment again. In order to get the decimal representation of number 7. So let's give it a shot. And there you go. Number 7 is represented down below. Our next special character is a semicolon. This is also known as a command separator. It is used to we use it to separate more commands that are more than one command that are on the same line. So how can we illustrate this? Let's just go ahead and delete this as we no longer need it. Again, we shall have some sort of a variable, so we can type in var for variable, and this can be equal. This, by the way, this declaration of a variable that I'm using, var, name, etc. You can type in whatever you want, pretty much. That is completely up to you. You could have written tra-la-la equals, I don't know, number 4. Yep, so there we go. Very simple than that. We shall type in var equals, and that's going to be, I don't know, let's say 10. We're declaring a variable. We're going to declare a variable called var that holds a value of 5. And now we're going to use an if condition to check if n is greater than 0. How shall we do that? Well, we type in if, and then we put a bracket. We shall use these quotation marks, $sign var, because we would like to get the value. How would we say greater than? This? How many of you think it's this? No. This is going to be used for redirection. It's dash GT, greater than. Also LT, lesser than. Very simple. So greater than, and we're gonna put some number here. I don't know. Okay, yeah, let's use a 0. Why not? Let's go ahead and close the brackets, and now we can use a semicolon and type in then. Then there was a case where we can do this, but we don't want to do it. We would like to type it in like this. Would like to have it on the same line. For what reason? I have no idea. I'm just using this as an example to actually explain it. I would always put it on the second line anyway. But there are some simpler examples. Let me just go ahead and show this one to you. So these lines are now commented out. They will not be taken into consideration. This is also an important part of commenting things. If you don't want a certain function to be taken into consideration, you comment it out to see how the code will function without it. If I type in echo, hey there, close this and type in echo again and say, you there? How do you try to imagine in your head what will happen here? What will be printed out? Just try to figure it out. Even if you fail, it doesn't matter. You've stimulated your brain to function in that direction. It's still number 7 because I haven't saved the file. So let's go ahead and save the file. Not quit, but save, meaning write the changes to the file. And let's go ahead and run this again. It says, hey there. And take a look at what's written here. Echo, you there. So we don't want echo to be printed out. This is a command, not something that we wanted to be printed out to the screen. Now take a look now compare this change. And here, let me make it a little bit easier for you. I shall run it again, so you have this output in the clear here. And I will enter insert mode. And let's go ahead and do this. Put a semicolon here. You see, even the highlighting has changed. Now let's write the changes and run the code again. Hey, you get something completely different. It says, hey there, you there. I know, right? My sense of typing sentences is awesome, but you get the idea. Now this is no longer part of a single echo. These are 2 separate echo commands, and this will be executed as a command and as opposed to just being a part of the echo statement that's to be printed out to the screen. Simple enough. Hopefully it's simple enough. Okay, so let's remove this line as we no longer need it. And let's uncomment these lines. Okay, so it's then down below we shall type in, actually no, we can do it here as well. Echo, why not var, just echo this. Nah, yes. So if it is greater, if this condition, because this condition can either evaluate to true or false, it can be greater than 0 or it can be lesser than 0. So this variable here, that has a value of 10, can be greater than 0 or it can be lesser than 0. If it's lesser than 0, this entire statement is false. If it's greater than 0 as the condition claims, then it's true. So if it's greater than, yes. And then we're gonna use another semicolon. Else another semicolon, echo, no. Right, right. Syntax error. So where have we made a mistake here? What seems to be the problem? Well, let's take a look at this, because when you make syntax errors in code here, it will usually inform you, well, it should always inform you down here and tell you what it is that is going on. So let's try to read it and let's see what the problem is. It says that the line 5 syntax error near unexpected token semicolon. So line 5, we have 1, 2, 3. What seems to be going on here? Only 3 lines. Why is it reporting the 5th line? Well, let's count them. 1, semicolon. 2, semicolon. 3, semicolon. 5. Where could the mistake be? Let's remove this. Let's try to run it now and see what happens. Syntax error. Else echo no. So what's the problem here? Well, obviously, if we have removed it, if you see how these things follow, take a look at this one and then take a look at this one here. See, they are the same pretty much. It says, if this is greater, then do this. Else, do this. So if we have removed the semicolon here, it would be logical that the semicolon doesn't exist here either. So no big deal. You can just remove it and then write first, syntax error, unexpected end of the file. Well, what do we need to do? We need to end the loop. We need to end the condition with something. So we shall do this. Oops, sorry. Insert mode. Fi at the end. And do this. Right? And there you go. Yes, it is greater than 0. So it prints it out. If we change the value here to -10. Oops. Right. No, it is not greater than 0. Now I hope that I have helped you out a little bit with these things here, with the debugging. You can call it debugging if you wish. The program basically tells you, hey, you have a problem on that line. Hey, I don't understand what this is. The machine is telling you. And then based upon that, based upon the output from the machine, you can correct the code and fix the things that you think that might be wrong or that are improper, something like that, that they don't actually function the way you wanted them to function or the way you have intended them to function in any case. So, bid you farewell, and I hope to see you in the follow-up tutorial. Next special character will be a dot. By typing a single dot after, let's say, certain command, I'll just exit bash. Oops. Let's say if we type in cd dot, cd stands for change directory. It changes directory. You can see your working directory by typing in pwd. This is print working directory. This is where you are at the moment. And if I did this ls, I would see what is in that directory. If I did it ls la, list all, so don't hide anything from me, you can see that there is a dot and that there are 2 dots. 2 dots is a previous directory and dot is the current one. So if I cd dot, that means that I've just literally entered the same directory where I am now. I know, sounds strange and weird, but so it is. But if I type in cd dot dot, I will go back 1 directory. And dots can also be used as destinations, not just by moving 1 step backward. This is like when moving files from 1 directory to the current directory with the move command. Or we can, for example, copy some things from 1 directory into another. And we can do this. Look, you might think that dot is pointless, which represents the current directory. But no. For example, if I did this, cd home chronic documents bash course videos, and I don't know. Let's just go ahead and copy that one. Sorry, not cd. cp is for copy. And since it's a directory, we would like to do, well, I don't really want to do recursiveness. So how would you copy this into a current directory where we are now? What would you do? Would you basically type another path to where you are now? Does this look simple to you, or is it simpler to just press a dot, to just type in a dot? So this will effectively copy this into this. This is probably not the proper form of the command. You would need a recursive option here to copy everything under this directory, but that doesn't matter. I could basically do this as well. What is this? This is a wildcard character. I will talk about it in a moment, but you see how dot can be useful. I mean, it can pretty much shorten the command by a very, very large extent. So we will be using it at some point of time in the bash later on, most likely through some examples, but there isn't really much to it. I just wanted to show you one of the ways in which you can use it. The next special character is a partial quoting or a double quote. Partial quoting will preserve most of the special characters within a string. Partial quoting is used when referencing some sort of a variable we want to replace with some sort of a value of that variable. So I know it seems a little bit of abstract, but let me just go ahead and give you an example. Let's go back into our file. And are you serious? Nothing in here. I must have opened up a new one. Okay, there we go. So vim first.sh. Excellent. So now I know that I'm in the right file. Linux is case sensitive, so for example, name and name are two completely different names just because of the capital letter. Anyway, so we will declare a variable colors, basically this colors, and we will make it equal to a string which composes out of three. We will make it into a string which has three parts to it. Let's put it like that. It's all one string, but we will use space to separate it. So black, white. And you see if I did this, echo, where is it? There we go. Oops, I misspelled that. So, colors, and here, colors. Let's write this down and run it. You see, it prints out. It prints out red, black, and white. If you're wondering why hash has been printed out here, it's because I pressed it on the keyboard while I was executing. So it prints out the whole string, but we're gonna do something with it now. Let's go ahead and delete this. Now we're going to use a for loop, like this. For col in space $, colors. Now col is a col. I could have named it something else. I'm just using this as a short version of a color. So col is a variable to which values are assigned, values in the argument list, and this is the argument list. The argument list can be a lot of things, but for the moment we're using this string as our argument list. So this variable that we're going to utilize here as an argument list will be looped through. So it will take red and black and white. God. White. My spelling is just amazing. It doesn't matter which keyboard I get. I don't know. I pretty much always get it wrong for some strange reason. Anyway, these arguments will be red, black, and white, and they will be listed through with this variable. So, first case, col will become red. Second time around, well, not first case. First time around, col will become red. Second time around, col will become black. Third time around, col will become white. That is the idea. In each iteration, the col will take the next value from the list. So let's go ahead and begin the loop and see what actually happens. these things are, when you explain them, they seem pretty abstract and strange, but then you see them run in action and things become a lot clearer. So echo, and then well, actually I don't need this, just call. So when you have a single thing like this, most of the time it won't need quotation marks, but if you have like spaces and something else, it's a lot safer just to put the quotation marks like this. So I'm not going to put it in this particular example, but I'm pretty sure that I will begin putting them from this point on, as it is a lot safer. Just in terms of errors, you know, sometimes you'll get an error and you won't know why it is, but it's just because you missed the quotation marks. So this is the loop. This is the loop scope. This begins the loop and this finishes the loop. The loop is done when when we reach the end of the scope. So let's go ahead and do this. Right. So you see, red, black, white. It just goes one by one and they are listed out. But you cannot appreciate how simple Bash is until you have created some sort of a code in C or C++ or something like that. When you start creating code there and you come to Bash, you know, you only then begin to appreciate just how much is it simplified. But then again, Bash, when you write something in a Bash scripting language, it's about 1,000,000 times slower than when you write something in C, so the program runs a lot faster. Anyway, so we haven't placed this in any sort of quotes. You see, we are primarily talking about quotes here. But if we modify this code by putting our variable colors within double quotes, the output will not be the same at all. So let's go ahead and try that and see what is going on. Okay. Right? Huh. What happened? It's red, black, and white in one line. Why isn't every statement in a different line? Well, let's have a look. In this particular example, the for loop, there is only one iteration. So there's only one pass. There's only one time that this loop will occur. It won't go 3 times like in the previous one. The double quotes that we have placed here from left and right, they are here to prevent word splitting. So this will not be split as 3 separate words as though it was some sort of a string array, but rather instead it will be used as a single word. So all of these 3 will be placed into this, and that will be echoed out. So you have 3 of them in the same line. I know it seems like it has went through it 3 times, but believe me, nothing of a kind has happened. This was just a single pass, while above you have it passed 3 times. And that would be the significance of the double quotes. Next character in line is a single quote. Unlike partial quoting, it preserves all special characters within string. Full quoting, for example, does not permit referencing variables. What we have done just now, so referencing over here, referencing a variable. It interprets everything that is enclosed with single quotes, literally. Except for, of course, again, the single quote. I have, let's see if we can actually do a demo here. Should get the same result, shouldn't get quite the opposite. We shouldn't get the same result. You see? This is what I mean. It does not allow for referencing the variables at all. Not gonna happen. It just takes this as it actually is, what we have written. It's not taking the value of this. It has no relation to this of whatsoever. this is just pretty much like echoing this word out. So we have basically placed what we have written on the screen into this variable, and then we have printed that out onto the screen, and that is exactly what you see down below. Sometimes it's useful, sometimes it isn't. But there you go, a simple enough example. Next character in the line is a comma separator. Basically, it links together a series of some sort of arithmetic operations, let's say. They are all evaluated and taken into consideration, but only the last operation is actually returned. So let's go ahead and see how this works, and let's go ahead and see what I have just stated, because I have a feeling every time I say something, until I actually show it, it's completely useless, because it doesn't mean that much. It's difficult to put code into words. It's so much easier to just present code as it is. So let's go ahead and type in let. Let is a command that performs arithmetic operations on variables. So we just say let, and we use the double quotation marks that we've just seen. And we're going to say that y is equal to, open parentheses, open parentheses again, x equals, I don't know, 20. And we're going to say comma, which we're using, so we're separating them, space 10 divided by, I don't know, 2, let's say like this. And then we're going to go ahead and close the quotation marks. Basically, we have set x to 5, and we have set y to 10 divided by 2. Let's go ahead and see what will actually occur here with a comma. Okay. My apologies, I forgot to close the quotes. This time I did actually forget about it. Nothing. Why? Do you believe that nothing has happened? Of course not. Well, maybe you believe it, but that's not the case. We just haven't printed anything out to the screen. So just because we don't print something out to the screen, that doesn't mean that the operation doesn't perform itself in the background. So let's go ahead and echo something out. Let's go ahead and echo y. Oops. Excellent. It's 5. So what do you suppose out of these two is 5? What is 5 here? Can you just conclude it by looking at it? Is the value of x 5, or is the value of y 5? So even though we have stated that y is equal to this and then comma to this, only the last one will be taken into consideration in this manner. We will see how this comes to be useful later on in the course, and how does this perform. But you see why is it important for me to show you? Imagine if you saw this somewhere in the code and you didn't know what this comma meant. You would not be able to effectively read the code. You would just spend time looking for it on the forums. And I know it might seem boring now that I'm explaining it separately like this, but believe me, it does have meaning. There is purpose to it. Okay, so let's go ahead and continue. We no longer need this. The next character that we will use is a double comma, basically. I know it seems strange. That is used in lowercase letter conversion. So let's go ahead and take a look how that works. Pretty much you just type in some sort of a variable. I don't know. We'll just use a reference. We'll just use something that I've named var. Let's name our variable so, and let's assign some sort of a string to it. What shall we assign to it? Okay, DSL nation, and let's just convert this to just some random letters to capital letters. Excellent. So now we have a string that is composed out of lowercase and uppercase letters. Now we would like to change the first character to lowercase. How shall we do this? Well, echo space. Again, this $, open curly brackets, type in var, and then type a comma. This is also another use of comma. Let's go ahead and write this. Execute it, and you see it converts it. So DSL connection. The first letter is actually a lowercase letter now. The first character has actually been converted to a lowercase. Now, what we would like to do is change all the characters of this word of this string into lowercase characters. Well, insert. Just double comma. That's it. Right? There you go. DSL connection. So we have converted it without any bigger problems. This can be very useful when manipulating files and sorting things out. These bash scripts can be invaluable. Okay, so I'm running a bit out of time. I'm going to call the tutorial here, and I'll see you all in the next one. Let us continue. Thus far, we've done a few, but there are many more to go. In terms of special characters, we are, I would say, 1/3 of the way through. So two more thirds, and we are done with this, and we can get on to, I guess, more important things. But all jokes aside, you do need to know this in order to be able to read the code. Anyway, next special character is one of the more commonly used ones, and that is the escape character, or as people tend to call it, backslash. But generally, it is referred to as an escape character. If, for example, a backslash is placed before a character within, let's say, an echo command, that tells the interpreter to interpret that particular character in front of which backslash has been placed literally. Let's go ahead and see what will happen. This is especially useful when you want to include double quotes in your output, which would be kind of difficult without it, or more likely impossible. So if I, for example, wish to type in echo, and I would like to output Linux is awesome, and I would like to output this in double quotes. So I would just like to wrap it around the quotes so that the output looks something like this. Linux is awesome. Look, this is how I would like my output to look like, with double quotes. Now let's see, can we achieve this like this? Right quit. Not right quit, just right. Let's run it. No, of course not. It's not going to output the quotation marks at all. But that's why we have the escape character. Yes. Okay. Insert. Right. So there. And there. Now, if we do this, look, it's going to output the quote marks. Double quote marks without any problems. So we will have that. Also, it's a good idea to use this with some other commands. For example, if we were to use grep, let's go ahead and clear this and do ls --help. You see, you get a lot of things here. But we would only like to know what the capital U option does. How are we going to extract that from there? Well, we're going to use this and then pipe, which we're also going to deal with. Pipe and then grep. And if we do this, capital U, no, nothing is going to be outputted. The grep is looking for some sort of a pattern that is passed here. Okay, so we can put this into quotation marks. Again, nothing is going to be outputted here. But if we do this, there you go. So grep is just pulling some sort of a pattern out of the standard output of the ls command. The standard output of ls command is being pushed into grep command, and then grep is looking for something to pull out, to grep out of there. And then you're giving it a pattern to pull out. But you see how escape characters can be useful even in trivial matters like these, and this is actually something that you will tend to use quite often. Oh, well, the encoding of one video has been just completed. That was the notification in the upper middle corner, in the upper middle portion of the screen. But anyway, you see how an escape character can be useful there as well. The following, what follows it immediately is the character called slash, which you are going to use probably very often. You can see it. I use it down here every single time I want to execute a command. Dot slash is pretty much for the execution of the command. Also, you would specify. You would use it to separate, for example, the certain components of a file name. If, let's say, you want to use the command change directory, and then you go to /home/ chronic /documents. By the way, if you're wondering how am I typing so fast, I am not. If you press tab once like this, you see, it actually finishes it for you. If you press it once, if there's only one option available. But if there are more options available, and if you press tab, nothing's going to come out. But if you press it twice, it's going to give you a list of possibilities. So you can just type in 2 or 3 letters of one of these possibilities and then press tab again, and it's going to finish it for you. So it's a really fast way of typing. That's one of the ways in which slash is used. But also, for example, but you would also use it in order to divide 2 numbers. So we can perform some sort of an arithmetic operation with the let command. So we type in, oops, I clicked on the terminal. Oh, there we go. So let space some sort of a value. So we're gonna just use a short version, val equals, I don't know, 500 divided by 2. And then we're just gonna echo out val. Of course, this would not work. Why? Because we need to reference the value. And there we go. It's 250. You see the script execution, and it's 250. One more time. There go, 250. So this is used for division. We have used it in the previous tutorials. I just didn't mention it, but it goes without saying this is one of the simpler ones. The next character that we're going to do is, well, not something that you would consider to be even a special character, but oh well. It's the back quote. It basically acts as some sort of a substitution for something. It takes the output of a command and it assigns it to a variable. So we can recycle this example and use it like this. So we have let val equals 500 divided by 2, echo val, that is 250. But now we would like to define val, val 2. So some sort of a, well, we're not going to define it as val2. How shall we define this? Some sort of a number. Let's go ahead and state that this is a num. Or why not val2? Why not? Why not? Equals, simpler this way, val2. And then this shall be equal to the variable $val. So this shall be equal to 250. How shall we do that? Well, we can output the value of val, and then we can put it in single reverse quotes like this. And do you believe me that now 250 will become the value will become the stored value of variable 2, of value 2, however you wish to refer to it. So right, Right. Sorry, did not echo it out. Let's go ahead and type echo val2. The quotation mark's not really necessary here, but hey, why not? You see, again, it is 250. This comes in handy in some sort of more complex things where you need to, for example, take something from the standard output and then place it into one of your variables in order to process it for a function, for example. It's not as complex as it seems, trust me. So the next character is a colon or a null command. Generally referred to as do nothing operation. Believe it or not, something like that is of use to us, and you will be using it, I assure you. Here's an example. I know it's a bit of an abstract term to actually come to terms with, to tell the program to do nothing, and you might wonder, well, why would I tell it to do nothing? Well, let's just use some sort of a variable, and let's say that variable is equal to 20. And let's use an if condition, this time in a normal fashion. So we're just going to say that this var is lesser than 15, let's say. Is it lesser than 15? No, it is absolutely not lesser than 15. It is greater than 15. But hold on. We will say then, so if it is a lesser than 15, then I want you to do nothing. Else, then I want you to do nothing else. Echo, not num, sorry, var, and then I would like you to finish the if statement. Okay, so let's see what happens. Okay, so echo 20. 20 is lesser than 15. But let's change the condition. Let's say 20 is not lesser than 15. Therefore, the else part of the if statement will be executed. But let's write something that is true, that will evaluate the true. So it's greater than 15. Is 20 greater than 15? Yes, of course. And that is the first case, then. So if you don't want anything to happen, if this is true, how would you do that? Well, you would just use the null command. Here you go. Nothing happens. So it's greater, so fine, don't do anything. Just leave it as it is. Now, colon, it can also be used in conjunction with a redirection operator, for example, to truncate file's length to 0 if the file exists, or if the file, for example, is not in existence, it will create it. I need to give you an example again, because this is a bit of an abstract thing to just talk about like this. You need to show it. If we had a file, let's create a file with touch. So this will just create a basic file. It's not a folder. So we will name this file. How shall we name this file? We'll name this file wood.txt, just for the sake of it. We don't need a txt extension, but we'll just name it for the sake of it. And if, for example, if that file had something written in it, for example, if we go ahead and do, oh, by the way, here's a very nice way of redirecting things. If you type in echo, and if you do this, and sorry, let's go ahead and, here is something. Use it. There we go. Now we would like to redirect the output of the echo command, the standard output, into a certain file. So wood.txt. Excellent. So it has been redirected. Now we would like to output the contents of the wood onto the screen. So we can use the cat command. Cat wood.txt, and you can see here is something, use it. But if we were to type like this, something else, and if we were to cat the wood again, you see the entire contents of the file gets replaced with what you have just written. How would you then add to this? Well, you would just use double greater than sign, something else, something more. There you go, something else, and then something more. Both have been added to the file. So very, very simple and very clean way of doing it. But what, for example, if you wanted to empty this file completely, well, wood.txt, enter, cat wood.txt, the file is empty. It's completely clean. So you use colon, greater than, and wood. So you've basically done the same thing with echo. You've redirected the output of this into this file. And what does this represent? This represents nothing. So you redirected the output of nothing into wood.txt file. Therefore, the wood.txt file has practically become completely empty. Similar to this, you can also use the colon in combination with double greater than sign, which is also a redirection operator, and the file would remain unchanged. However, if the file didn't exist, then it would be created. For example, let's go ahead and remove wood completely. You can see it's not there anymore. And let's go ahead and redo this command. And let's do ls. You can see that wood.txt is clearly there. So it exists. But what if you did the double greater than sign? And let's just go ahead and type in vim, or not. Let's just scroll up here. What do we got? Okay, we filled it up with something. Now we've used this to delete everything. But if we use the double greater than sign, now let's go ahead and cat wood. You see, it has remained completely unchanged, because you have just added nothing to something. That something will remain exactly the same, as nothing new has been really added to it. So very, very simple, no big deal. You can there's a failsafe option that it will create a file if it doesn't exist, etc. Not that complex. Anyway, I'm gonna call the tutorial here, and we are going to go ahead and continue with some more characters in the follow-up. I have cleaned the script up completely. Hopefully by now you know how to do this. Open it up and delete everything in it. Now, the next character that we will do is an exclamation mark. This one is used to negate or reverse the result of some sort of a condition or a test or exit status. So let's use the following example. I mean, it's pretty similar to the last example we've had. I could have actually recycled that one, but no big deal. So we're gonna say that we're gonna have some sort of a variable. So var is equal to 10. Down below we're gonna have a if statement. This is gonna be var, and look, now we're not gonna use greater than, lesser than, or something like that. Rather, instead, we will use not equal to 0. So we're testing whether the number that we pass, whether the value that we pass is is generally just not equal to 0. It can be less than 0, greater than 0, as long as it is not 0. Then echo, not, and else echo yes. So if it is not equal to 0, then it's going to print out not. If it is equal to 0, it will print out yes. Very well, right? syntax error. Where is the error? What have I done wrong? Let's have a look. First, have I first of all committed the changes? Yes, I have committed the changes. There is a problem at the end of the file. Well, only one thing. Fi, I need to finish the if statement. And there you go. It is not equal to 0. If I go ahead and change it, if I write the changes, then it is equal to 0. So now it's printing out yes. Excellent. Next character in line is a wildcard or asterisk. So you would just, this is an asterisk. It is a wildcard character, and here's how you can use it. For example, let's go ahead and create a few random files. So touch to create them, and we can specify as many as we like pretty much in one line. Test1, test2, test3, test4. And now imagine that you have 100 files, all of them beginning with test, or all of them pretty much having the same beginning of the file, or having at least something in common. How would you delete them from a terminal? I mean, in GUI, you will be able to select them, but even then, selecting 100 files that are placed randomly throughout a certain folder, not exactly a simple task. So how would you delete them? What would you do? Use the rm remove command and specify test1, and then remove test1, and then remove test2, etc. Or you could do this. So remove everything that has test in it, that begins with test, and it can end with anything else. So wildcard will match everything. Let me just confirm to you that the files are there, so you can see that they are there. And now if I type in rm test and use a wildcard, press enter, they are no longer there. So wildcard is simply used to match pretty much anything. If I could compare it to something, it would be a joker card. Basically, when you're playing poker or something like that, it substitutes pretty much every other card without any problems. So, however, this can also be used in an arithmetic operation for multiplication, namely. So I'm not sure if we've actually used multiplication before, but here we go. Let's give it a shot and let's see how it actually looks like. I'm gonna go ahead and turn insert, and let's go ahead and delete this. So we shall leave the var. We will make it into, I don't know, let's make it into 100, and we shall use let var equals 100, and we shall multiply 100 by 10. That should be 1000. So we shall type in echo. Wait, let's do this. Let var2 equals 100, and we're gonna say here 10. This is gonna be huge. No, we're not gonna say 10, we're gonna say 3. And then echo, we shall use quotation marks, oops, var, and then again var2, and that's all we really want. So let's go ahead and write the changes. The reason why I'm not explaining it is I want you to think about it. So var1 will basically be equal to 100 times 10, but var2 will be 100 asterisk asterisk 3. The clue to this, the clue to the answer is that I didn't use 10 down here, that I said that the number would be absolutely huge. So what do you think that this will do? What do you think that will happen here? Here, I'll show you down here. So this is 1000 as we have predicted, and this is so 3 and 3, this is 1 million. Basically, this is exponentiation. You use this for multiplication and this for exponentiation. Simple enough to understand, no big deal, no hassle there. Next character would be the question mark, and this would be a test operator. This can be found in expressions, and it refers to a test of a certain condition. So let's go ahead and see how that looks like. It's a little bit, I wouldn't say tricky, but can be a bit annoying to read through it. So again, we can state that var is equal 10, so let's just use the standard number. And now we can go ahead and begin writing our example. So go ahead and type in echo space $, and we're going to use open parentheses, open parentheses. Let's just rename this to variable 1. And we're going to have var2 as variable 2, and we shall make the value of variable 2 dependent on whether or not the value of variable 1 is greater than some number or lesser than some number. How would we do that in one line? I know it's rather simple to do it with an if statement, and we have actually done it before, but here's an example of how you can do it in one line using a special character question mark. Simple enough, not a big deal. It can seem a little bit confusing, but trust me, you can handle it. So just equal to var1, and then we shall say that var1 is lesser than 20. Now we shall place a question mark here, and then we will give it two values. So the first value will be 1, and the second value will be 0. You could have placed pretty much any two numbers here that you desired, no big deal. And let's just go ahead and close this. Fantastic. Write down. Run the script, and there you go. The value of var2 is 1. So this statement you can read as follows. var2 is equal, and then it shall be, the value that is assigned to it will depend on the outcome of this condition. So is variable 1 lesser than 20? If yes, assign value 1. If not, assign value 0. Now, let me just show you an equivalent of this with an if statement. If you wrote it like this, if, then if you typed in, well, let's just read the condition from up above. So var1, like this. Okay, so like this, lesser than 20. Close the brackets. Then var2 shall be equal to 1, else var2 shall be equal to 0. Finish the if statement and type in echo var2. Okay, so let's run the command. Let's run the script. And you can see that these two match. If we type in, if we change this variable to be 100, now the value will be 0. So there you go. Both conditions are the same. They will evaluate to the same pretty much, so no worries there. Okay, so I shall wrap it up here and continue in the follow-up. Welcome back. Our next character is characters, basically parentheses. Now they're used in order to store groups of commands inside of them. And you should also keep in mind that a group of commands inside of it will start a subshell, and the variables inside of it cannot be read by the script. So that can be problematic. Let me just show you what I mean. We will have a separate part where we will deal with subshells. I will explain them in far greater detail there, but let me just show you what I mean by this with a practical example. If I type in var equals 5, and then down below we will use this, again we will use the same variable and we will initialize it to some different number, let's say 10, and of course we will have this at the end, semicolon. because these are groups of commands. So you put 1, 2, 3, 4, as many as you like. And now let's go ahead and echo out the value. So the value of var. Think about it. Which value will it actually print out? Will it be 5 or will it be 10? Let's run the script down below and see. 5. Why? Because as I just said, these initializations, these variables cannot be interpreted or read, well, cannot be read by the script. Now, parentheses are also used for array initialization. What are arrays? You need not bother with that now. Why? Because I shall explain it later. It is a bit more of a, I wouldn't say complex term, but something that definitely comes a little bit later. It's not that those are not the late stages, but just a little bit later. So, for example, if we have an example, if we have something like this, so colors equals, and we have red, white, and brown, and what shall we use next? Purple, etc. Doesn't matter. This is sufficient for an example. So this is an initialized array with these values. And if we wanted to print it out, we actually used this before. If you remember, in our for loop, in one of the examples where I actually used a for loop. So basically, colors now has these values. So red, white, brown, and purple. And depending on how you want to print them out, you can separate them, or you can print them out all on one line or something like that. Whatever you wish. We basically did this a little bit before, so I'm not going to go too deep into it. I just want to show you how these parentheses are used. So basically put one here, and then you close it at the end, and then you write the values of this array. Basically, first position, second position, third position, fourth position. Simple enough. We will deal with arrays in a separate tutorial. I do believe it is better like that, so that you can understand it a bit easier. These next few characters, they will be rather simple. For example, you have curly brackets, which go like this. But then you have a format in which the information is actually written in between them. We can use the color example again, actually. You can type in echo space, and then we shall use these escape characters along with a $sign, and in between let's write what shall we write? Test 1, test 2, test 3. Excellent. So now we can go ahead and close this and use a $sign again. I know it is a bit of a strange usage, but what will happen here is that it will output all enclosed elements, and they will all have a prefix of a $sign, as though they had a prefix of a $sign. So another nice usage of a $sign. Let me just show you this. You see, it has one, and then it has it at the beginning, and it has it at the end. It has it at the beginning. It has it at the end. I don't know, because you have these escape characters here. You see escape character, and then you have something in here. This doesn't necessarily need to be a $sign, but I just placed it there just so that you can see that it is not always true if you have a $sign that it is necessarily a value. So you basically just put it here, and that's it. With the escape character, I could have placed something else here. Like, for example, quotation marks here. Actually, let me just go ahead and put the quotation marks just to show you. Oops. There you go. Let's go ahead and output it. Hey, wait, what do you know? We have quotation marks at the beginning and at the end of each and every one of these statements. So this is just one of the ways in which this can be used. Another example would be when you want to actually output the contents of multiple files into one. So what would you do? I can actually exit here to quit. Do you remember how we use the cat command? So if we cat first.sh, we will see that there is some sort of a code in it. But what if we had, for example, multiple files, and we would like to take whatever is in those multiple files and output it, take it basically from them and put it into a single file? How would we do that? Well, you would use cat, and then you would use these curly brackets. You would type, I don't know, some test file 00, and I don't know, test file 01. I don't have these files, they don't exist, I haven't created them. I'm just typing it in as an example of how I want it to be. And imagine that you had like maybe 10 more of those. I would use a redirection, and I would redirect it to some file that I wanted to redirect it to, which would be test 00, and we shall change this to 01 and 02. So I know I have a bit of a weird name. So I have one file here, and I have another file here, and I would like to output their contents with cat, but I don't want to type it. I don't want to output each file individually. I want to output them all, and to do this in one line, to issue a command which will do this for us in one line. So this is the one line I'm referring to, not the output. We would need to use these curly brackets, curly parentheses, however they're called. So you just do that, and you put as many files as you like here, and then you redirect your output into this file, and there it will actually be stored. Quite convenient at times. You can rest assured of that. Anyway, there are some other examples with this. Feel free to play around as much as you want, but here's another one which can be rather interesting. You can create a loop without a loop. I know, sounds strange when I put it in like this. So instead of writing some sort of a for loop or a while loop or something like that, if you just need a quick output, for example, of certain amount of numbers, of a certain range of numbers, you would just do this, echo, and then 1 dot, 2 dots to 10. Let's go ahead and type in 0 and 9. You can go from 1 to 10 if you like. You can go from 1 to 100, whatever. Just giving examples. And this will output all the numbers in between them. So this will output a range. So you see, you have a 0, and you have 1, 2, 3, 4, 5, 6, 7, 8, and then you have a 9 at the end. So this is very convenient. It's a very fast way of writing things as opposed to actually creating an entire loop. It is not something that you really want to do. Now there is another way of using these curly brackets, and that is separating a piece of code. So they can represent a block of code. This will create basically an anonymous function, a term not that well known to you now, but hopefully by the end of this course you will be very familiar with it. But unlike the standard function, in which the variables defined are hidden to the remainder of the script, the variables inside this block of code will remain visible completely. So here's what I mean by it. Let me just give you an example. It's always better that way. So if we have var1, for example, equals to 1, and var2 is equal to 2, and now we would like to create a separate piece of code here, and we shall use the exact same variables like we have before with parentheses. So var1 is equal to 10, and var2 is equal to 12. This is going to be 11 for easy referencing. And let's go ahead and close this. Then echo $, var1, var2. Okay, so what do you think we will see? Shall we see the values 1 and 2, or shall we see the values of 11 and 12? Think about it for a second, pause the video if you like, but don't think about it too long. Let's run it. So we shall see values 11 and 12, because as I said, this actually makes it visible, even though it is a separate line of code, so no big deal. Anyway, I shall cut the tutorial here and continue in the follow-up. Welcome back. This should be the last tutorial in the unique or special characters chapter. As soon as we're done with this, as soon as we're done with this particular tutorial, we will move on to other things. So now we're gonna deal with a bit of logic. One of the first thing, you have these characters, the two of them, which represent the logical OR and logical AND. And you can combine a few smaller conditions into one main condition, so to say. Let me just demonstrate this with an if statement. So for example, if I have if like this, if I go ahead and open up a bracket, just need some variable var equals 1, and then I shall say here var is greater than, 0. Okay. But what if I want to implement additional conditions here, which will form the main condition? So hey, why not use the logical OR? This is the logical OR. So same like pipe, what I've mentioned before, but instead of having one, you have two of them. That's all. Now we move on to the next condition that we're going to set. We shall say var, $var, and it shall be equal, so -eq to, let's say 10. And then echo then part, or one or both conditions are met, or one or both conditions are true. Let's put it like this. And then else echo neither one of the conditions is true, or both conditions are false. Finish. Excellent. So sorry for the delay there, just had to write it down and use my infinite imagination to come up with these sentences. But we have one condition, and I am obviously observing them as two separate conditions in these echo statements that I'm making. But in fact, they're not. So this entire line, this is one condition, one simple condition. Why? Well, either this can be true or, so this can be true or this can be true for this entire condition, for this entire statement to be evaluated as true and for this piece of code to execute. Only in the case that both of them are false will this bottom case be executed. So variable is 1, obviously that's greater than 0. Is it equal to 10? No, doesn't matter because one of these conditions has been satisfied. Therefore, this entire statement will be evaluated as true and this part of the code will be executed. Let me just show it to you. Echo. Actually, I don't need anything else. I can just you can just write it and run the script down below. It says one or both conditions are true. But if we alter this, let's say 0 here, keyword, it says greater than 0. Both conditions are false. So if only the case that both of them are false will this statement be printed out. Now there is another thing which we can do, and that is the logical AND. Let me show it here. It goes like this. And %sign and %sign. And now both of these conditions need to be true. Both of them need to be true in order for this statement to run. Here, let me just show you. If only one of them is true, you see both conditions are false. Still, this will run and it's not going to happen. So both of these need to be satisfied. So if you have more than one condition, you just tie them up with AND. If you want them all satisfied, or if you just want one of them satisfied, you use OR. Later on, we will be using these in a more extensive manner, most likely in the later stages when we use more complex scripts. They will come quite in handy, as this is something that is relatively frequently used and it has immediate practical application. Excellent. So our next character is a dash, so a minus sign, like this, you see, but just one. And this is used to denote optional prefix. Look, if I do this, right quit, and if I type in ls-h, oops, won't work like that for ls. But what else do I have? cd-h. Will it work for cd? Yep, there. Nope, it won't work for cd either. But ls-help will definitely work. I'm just trying. You usually have these formats. So you type in a command and then you type --help, or you can just type in -h for some commands, and for some others you need --help, which is a little bit inconvenient sometimes. -h. Excellent. So you see, this can be. This is an option that is used in a command. You see, but it doesn't necessarily need to be with help. It can be with something else. So, for example, if I type in ls-l, you see, we're still using the dash, and it's useful in order to actually in order to give arguments to a function, and then that function can behave based upon what we have asked it, what we have actually passed to it. What sort of arguments have we passed to it? Okay, so we have seen this previously. I mean, I've placed it in front of GT greater than and LT lesser than and EQ equal. It was always dash EQ dash LT dash GT, and so on and so forth. So, but when used with, you can also use it for redirection from standard input to standard output, and vice versa. So if we type in something like this, cat, nothing there, because we are basically redirecting nothing to nothing. Nothing should happen. I mean, this is just going to spin around for a while, but no big deal. I shall give you some. I'll give you some practical examples, but this can come quite in handy, primarily because it all depends on how you use it. So it can be used in order to basically access the arguments of a certain command. It can be used for standard input and output redirections. I will show you this through the scripts later on. And it can also be used as a minus sign. So it all depends from the context in which it is used. Now the next characters that we have, I'm pretty sure that you're familiar with them. You have plus, you have minus, plus. Where is it? Frustrating. Yep, there we go. You have modulus. And of course you have division. So these are all some sort of operations that are conducted. Anyway, the only one that you're not familiar with here, so this is minus, this is plus, this is division. Well, it's too bold of me to say that you're not familiar with it. Too stupid of me to say it like that, but that might prove something that you haven't encountered before, but I'm sure that you have seen it in school or something like that. Perhaps it is not denoted in this fashion. Well, it's definitely not denoted in this fashion, but here, let me just show it to you. So, this is modulus. Look it up on the net if you like. If not, listen to how I explain it, although I am by no means a mathematician. Var will be set to be the remainder of the division between two numbers. And this percentage sign is a modulus and represents the remainder of a division. So, if we were to divide 5 by 4, and we won't use this, we will use let var. So, if we were to divide 5 by 4, what would be the remainder? Well, obviously 1, because 4 goes into 5 once. 1 times 4 is 4, and we have 1 till we reach 5. So 1 is the remainder in this case. And how would we write that? Well, we would just use our sign and then 4. And then we shall echo var. There we go. So write 1. There you go. That's the modulus. So no big deal there. Fairly simple and easy to understand. Now, the next character is tilde, or home directory. So this is basically a shortcut that is used to switch to the home directory of the current user. And I am in my home directory, but I shall go backwards. And instead of typing this home chronic and going there, I can just type in cd tilde pwd, and there you go. I am in home chronic immediately. So cd space tilde will always take you to the home directory of the current user, which is quite in handy because it saves you quite a bit of typing. And if we were to, for example, you can also use these commands. Well, I can't use it with cd, but you can type it like this: echo, and we shall place tilde and plus. You see, this is the tilde plus is the current working directory as well, and that's going to echo out the current working directory. And if you use tilde and minus, that is the previous one. You see, the previous directory that we have used. And okay, we won't need any others. I'm just trying to think of, do we need anything else? Well, do you remember how we did conversions to lowercase letters? Well, let's just do the conversion to the uppercase letters and let that be the end of it. The rest we shall do along with the script, because I really don't want to burden you too much with fragmented content not being shown together with the script. But I mean, I really had to do it, otherwise you wouldn't understand anything in the script. It would be too confusing. Next character is the caret symbol. Oops, asterisk. Nope. There we go. So on my keyboard it's Shift 6. Anyway, this is used in uppercase conversion. So let's go ahead and take a look. It functions pretty much as the lowercase conversion. I really don't see anything that much different from it. VIM first. So this should be fairly simple. Works pretty much in the same fashion. If we type in some word, and if we set it equal to test, I don't know, let's just leave it at this, and then we can type in echo space $, curly brackets, some word, and as before, if we just type in, if we just type in 1, it will convert the first character to uppercase. Here, let me just show it to you. Yep, there we go. So the first character has been converted to uppercase. But if we just alter it a little bit and add another one, see that now everything is in uppercase. Fairly simple to use, no big deal there. So in this chapter, well, in this subchapter, we have seen the special characters that are used in Bash scripting language. And we have seen the purpose of each. So we have seen what they do. If you didn't catch them all, you can of course rewatch the tutorial. But you know, as we utilize some of the scripts, as we go through some of the other subjects, I will repeat periodically some of them, so that will settle well in your memory. Welcome all. Now I shall talk about variables and parameters in Bash. So variables, they're basically labels or some sort of names used to represent certain values or sets of values stored somewhere in the computer's memory. We can use variables both for arithmetic operations and string phrasing. This we will work out through a series of examples as always. Now what is important to understand is that the variable name and its value are not the same. Let's say we have a variable num, or number basically, or just let's say, actually let's do a better example. Let's say that we have a variable called var, so var. Then var represents the variable name. To get the value of the variable, we used to add a $sign as a prefix to the var, to the variable name. So this we have used many times by now in the examples, but let's just go ahead and see how that actually works. Let me just go ahead and explain that part in particular. So VIM, and now we're still going to stick to the first. I don't know, when we get to the major chapter change, like when we skip on from basics onwards, I think I shall change the script name to second or something like that. But you can name it whatever you want. Mine is first.sh. If yours is something else, that's perfectly fine. So as before, we can type in, I always click on the second screen where I have my notes, so sometimes don't click it immediately here. Excellent, so now we're in insert mode. Let's type in var equals 10, and if we echo var, that will actually not echo the value of this. It will just echo literally letters VAR, and down below we can use what we have been using thus far, var. So these are two completely different statements with dramatically different effects. You see, it will output var, and down below it will output 10. So the name of a variable is not the same as the value of the variable. We have to use this $sign as a prefix if we want to work with variables. However, there are some situations when a variable doesn't actually require a $sign. So let's just go over them. The first one, can you spot the first one on the screen now? The first one is in the declaration part. So you just type in the declaration and then you assign a value to it. So obviously you don't need a $sign here to assign a value to a variable. Now there is something called unset, and we can say num, well, not num, I can say var. In my notes over here it's num, but for some reason I placed it num, I suppose, because I'm using numbers as demonstrations for demonstrative purposes, but doesn't really matter. So if we type in unset var, this will actually make var into null. So if we type in echo var, you see, there is literally nothing that is printed out. So it's not being converted to number 0, but null. So there is nothing in it. There are some cases of exporting, but we're going to do that later on. I don't want to burden you with it now during the section that deals with basics. That's a little bit more of an advanced subject. And there is just another example which I would like to illustrate before you. There are some others, but as I said, we'll deal with them as the course progresses. But if we have these parentheses, then you will not need them. Which is basically, again, setting the value. If you remember, we used to use var1, and we set var1 equal to some number. I don't know, let's say 4. And down below, we have created these parentheses where we have stated that var2, where we made var2 dependent on var1 value. And then we said like lesser than, I don't know, 10, lesser than 10, then we shall place a question mark 1 and a 0 here, and then we shall close these, and down below you can type in echo var2. So you see, we didn't need a $sign here. So we are assigning a value here, obviously, okay, but what of this? So we're just using the name. So in situations like these, you won't need a $sign. These are very specific cases. But I suppose you're going to know it by the rules, but eventually it will just become second nature to you, and you won't actually think about it that much. It will just seem right. The same way you can speak English language. Let's say you were born into it, or you have learned it, and after a certain time of speaking, you basically stop thinking about it. You basically stop thinking whether the grammar is correct or false, and 90% of the time it turns out to be correct, and people can understand you. Well, this is also a type of a language that you use and that you learn. So after you've learned it, you're obviously not going to rethink grammar every time. Rather, instead, it's just going to come intuitively to you. Okay, so let's move on. We can assign variables in 3 ways. First way, and the most obvious way, is the one that we have just used. So we have stated var1 equal to 4. Now there is another way in which we can assign variables, and that is from the read statements. So the read statement will actually read the user input, will actually take the user input and put it into a variable. Here's how that looks like. This is also used rather often. Read, and we shall state var2. But before this, let's just make it meaningful. I mean, there's no technical requirement for this, but this is for our convenience. Echo, type in some value. Excellent. And then we're going to say read var2, and after that we shall echo var2. Fantastic. Now let's run the script. It says type in some value, and it's waiting for us. Actually, let's quit it. Let me just clear the screen so you can see it better. Type in some value, and now it's waiting for me to actually type it in. So what shall I do? Well, let's type in 8. And there you go. It prints 8 out onto the screen. Very simple. So we can also assign values to variables in this fashion, which is very nice. The third is, well, it's kind of used in a loop. Here, let me show you. It's not kind of used in a loop. It is used in a loop, but to an extent, I guess. Look at this. If I, for example, use a for loop, we will deal with loops separately, so you don't have to worry about that. So for var in, I don't know, 1, 2, 3. So this var is basically a variable and 1, 2, and 3, they represent a list of arguments for the loop. And this is going to go through 3 iterations, and variable var will take on the next value in the list. For each iteration, this variable will take, let's say in the first iteration it will take the value of 1, second iteration value of 2, third iteration the value of 3. Here, let me just show you this. It's rather simple. Echo $var, done. Right? And there you go. So it prints echo var. Well, let's make it even clearer than this, and let's state echo $var. Oops. Let's do it like this. What does the matter? Oh, okay. Value of var. Sorry if I misspelled that. Value of var is excellent. So let's go ahead and write that, and let's run the script again. So it says value of var is 1, value of var is 2, value of var is 3. So that is how you assign these values to. That is how you assign values to a variable. Anyway, I'm going to cut the tutorial here, bid you farewell, and we shall continue on in the next one. Welcome back. Now let's go ahead and take a look at some of the important properties of variables. The first thing that I would like to do is have a look at this. So quoting variables will actually preserve the white spaces. Here's what I mean by it. So if I declare a variable like this and I assign some sort of a value to it, and then I use like 3 or 4 white spaces, and then again like this, L. It doesn't necessarily need to be in this format. This is something completely random that I have written. Write whatever you wish. But down below, if I type in echo $var, and here if I run it, you will see that not all of my white spaces have been preserved. Problem. Now this is why I said at the very beginning that it is a very good idea to always use the quotation marks, double quoting signs here when outputting variables with echo. Notice how it will change now. And if I run it, look, it has preserved all the white spaces here without any problems of whatsoever. They are all printed out just because I added quotes. However, if there is for example, if there is a white space within the variable, then it will need to be quoted. Now, if I just go back here, so let's say I wish to declare a variable, and I say equal, and then I do this, test 1, test 2, test 3. Okay, so this would be a correct declaration. And if I was to write this and run the file, you see it will output them normally and everything will be correct. This would also be correct. So if I remove these, no, it looks a little bit strange, but it should also be correct, at least to my knowledge. Okay, sorry. You need escape characters for white spaces here. Now, let's go ahead and write. So this is also a correct way of writing it. So you see, again, we get a proper output, no problems, it all comes out. But what I have just done is what I have also wanted to demonstrate. If you remove these, and if you just declare a variable like that, like this, and if you save it, we will get command not found error. So this is an improper way of declaring it. You need to be a little bit aware of these things, how they work, and be aware that there are multiple ways of doing certain things. Different people code in a different fashion, and more often than not, you will actually be required to read somebody else's code which is never a pleasant experience, believe me. I'm not just talking about Bash, this is in general for pretty much all the programming languages out there. It's never a good experience to read somebody else's code and to try to make sense of it. Anyway, you can also set a variable to null. So if you just delete this, and if you leave it like this, you can save it. This is also correct. Nothing wrong with this. Nothing will be outputted. The value is null, not the string null, not the value of 0, but the value is pretty... I do not know how to put this, but it's nothing. So the value is nothing. Let's put it like that. That's when you say null. Anyway, you can also set multiple variables on the same line. You can separate them with whitespace. So let's just go ahead and do this. Let's go into the insert mode. So I can say that var1 is equal to, I don't know, 10 or 11, and var2 is equal to 22, and var3 is equal to 33. And if I go down, if I echo var1, and I do this var2, var3, you see, they are properly declared, everything works out. So you can declare them on the same line. Not the best of ideas, though. Let me just tell you that. You see, in the just a moment ago, I've shown you how just by not quoting a variable, sometimes it can display an improper output with white spaces because it omits certain things. But this can also cause some problems later on. You will see it as we continue to code. So it is way better just to do this. No big deal. It will not harm you or hinder you in any way. Just put every one of these into a separate line, and that is it. Nope, you will avoid a lot of headache at a certain point of time. Of that, I assure you. Okay, so no, we don't longer need these. Uninitialized variables. The one that I have just showed you has a value of basically it has a value of null. It will print out an empty line. So if we type in var equals nothing, echo, and then do this, var, and down below we can actually do this. We can set the var, so we can set the var to 9, and then echo var, run it like this, and you see the value will in fact be 9. Now what we can again do is set the value. We would like to change the value of the number. Oops. Var is now equal to 10. And now we will echo var again. So, right. You see, now we have reassigned the value. First we have initialized it to null, then we have assigned 9, and then we have reassigned it to 10. We can even go ahead and unset the value. So we could actually just type in unset var. Sorry. We need to echo it out so that we know what has happened. Echo out var, and there you go. So it had we haven't initialized it to any value. It's basically null. And then we've assigned a value of 10. Then we've reassigned the value to 10, and then we have unset the variable, the value of the variable once again. I know, right? So very simple, no big deal. Just a list of these lines of initialization and unsetting the variable names, unsetting the variable values, and setting them to something else. This you will do very often. Uninitialized variables in an arithmetic operation, for example, if you were to add two numbers, let's say like this. If you're just wondering what is it. Okay, so var, and let's go ahead and type in that let, I don't know, some var1, we shall have var1 that is equal to 10. And down below we shall say let var plus 10 echo, what would we like to echo out? So var plus 10, actually let's use this one. Let's not do it like this, because I could have done it in a simpler way. I didn't need to use let here. I can do this. Look, pay attention. Var plus equals 10. We don't need var1. What do you suppose I have written here? It's var plus equals 10. Well, this is the same as me writing let var is equal to var plus 10. You see? Now, this will, var, since it's uninitialized, since its value is null, this will be treated as a 0. So in arithmetic operations, this value is treated as a 0. Even though when you echo it out, it echoes out an empty line. There's nothing on it. So 0 plus 10 is equal to 10. 10 is equal, now 10 plus 10 is 20, so we should echo out 20. Echo out var, and just to show you, we can do another echo here, so you can see how the variable changes. You see, it's 10 and then it's 20. It just goes one after another. This is how you can treat them. This is very important because since this is treated as a 0 in arithmetic operations, that means that when you multiply something, it will become a 0. Very important. Also remember that you cannot divide by it, because you cannot divide by a 0. That's going to cause a lot of problems for you. Now we can assign a value to a variable as well using command substitution, but we have done a lot of that. However, well, we haven't done really a lot of it, but we did do a little bit. Let me just show you a few other things in regard to command substitution and assignment of values through such a process. So if we were to type in, I don't know, hi is equal to reversed quotes. Remember, we have used reverse quotes. I have explained what they are. And if I type in echo test, this is also another way of assigning a variable. And if I type in echo, and I would like to echo out the value of hi, this will give us test. So it will take this value and put it into this variable here. This is also another way of assigning the value of a variable. There are more practical examples than this, because this is just an echo command, but you can also use this ls home. Look, you can combine it with Linux. You can basically combine it with the commands that you use and get their output. So ls home chronic, and this should be enough. Let's say, look, I have now gotten the list of all the folders and files. Well, not all the folders and files, there are some hidden ones, but I could have passed in different arguments. And they are all stored into a variable, which I can now manipulate, which I can now play around with, which I can customize to suit my particular needs. Now, there are some cases where you can actually use parentheses as well, like this. So if I just remove this, and I can still use the ls command, it's a fairly straightforward and a simple example, and I can remove the quotation marks, can just open the parentheses and close it. And if I type in -LA, down below, I shall simply echo it, no big deal. I know that I have a stupid variable name hi, but oh well, no big deal. You see, now this will not work. Why won't it work? What are we missing here? Can anybody see? Well, we need a dollar sign here, and we need a dollar sign here. Why? Because this is a variable, and now we have performed some sort of an operation here, and we would like to take the result of that operation, convert it into a reference value, and place it as the value of this variable. And if we do it, you see, I will get the long listing of all the folders and files, all the ones that are hidden and that are not hidden. Very simple. So L is for long listing and A is for all. Bash variables, they don't have a type, which is very convenient for us as the users, but not so convenient for the machine, as these kind of things can be expensive in terms of RAM. They are the variables here, as they don't have a type, they are character strings by default. However, it is possible to perform arithmetic operations and comparisons if all characters are digits as well. This we will see in the follow-up examples, but before I go there, let me just tell you why what these types are. For example, you have in C programming language, which is a lot faster than Bash, you would have, but look, I just say that it's a lot faster than Bash, but doesn't necessarily mean that it's better or worse. Why? Well, C is meant for a certain set of things, for a certain set of tasks, and Bash is meant for another set of tasks, which would be ludicrous to do in C, and there are certain tasks which would be ludicrous to do in Bash. Simple as that. So, what are these types? You won't need them in Bash, but I figured it would be nice for you to know. You have an int, you have a string, you have a char, you have a float, double, not sure which one. I think actually this is pretty much enough. There are definitely more than this, but it's okay. So what is an int? It represents an integer. Integers are numbers like 1, 2, 3, 4, 5, 6, etc. If you don't know what an integer is, well, just use your favorite search engine and look for it online. It's an English word, nothing else. You use it, I do believe that everybody has mentioned it 100 times through elementary school. String. String is something like this. You put it in quote marks and then you say, hey, how is it going? What on earth is going on? So this is a string. And down below, a char would be a single letter, so A, or B, or T, or something like that. A floating point would be 1.345, something like that. So with these floating points, basically floating point numbers. Sorry, not my bad. This floating point number would not be this. This would be double. Floating point number would be 0 in front, and then dot, and then the numbers behind the dot. And down here, the double would be 1 point something, or I don't know, 10 point something, etc. You get the idea. Why is this important? Why would anybody want to declare? Why would anybody use these? Well, in C, you would say, instead of writing, you would say int var, and then var is equal to 10. And this var can only be an integer. It cannot be anything else. Why is this important? Well, because all of these things, when you declare them, they reserve memory space. It is not significant for you now, but in huge lines of code and for an operating system or something like that, it is the difference between using larger amounts of RAM or lower amounts of RAM, which is very, very important resource-wise. For example, integer will take far less RAM when declared as opposed to a string. A string will take a lot more RAM than an integer. and so on and so forth. All of these values, all of these variable types, they will take different amounts of, they will reserve different amounts of RAM, because when you start the program, the compiler will go through it, the machine will go through the code and will say, okay, I have an integer there, string here, etc. Reserve this much RAM for the integer, reserve this much RAM for string, etc. And the rest of the machine will not be able to access that amount of RAM. These are very small amounts of RAM. They're like very, very, very small. I'm not talking about megabytes, I'm talking less than megabytes. So you don't have to worry about it that much in Bash. But when you're writing a code for an operating system or for a game, it is very important to play around with these things. But in Bash, for example, if you just wanted to use some scripts to install a program or something like that, obviously this will not play any sort of a role pretty much. Anyway, we will continue on with these arithmetic operations and comparisons in the follow-up tutorial, as I am running a little bit short on time here. I just wanted to tell you what these types are, even though you won't encounter them much or at all in Bash. Welcome back. Okay, so let's have a look at those arithmetic operations. For example, if all characters are digits. Let's go ahead and try it out. So we are in insert mode. And for the sake of things, let's use num this time. Say equals to 1100. So 1100. Now we shall type in let num minus equals 10 and echo out the value of num. Thank you. Let's go ahead and run. And you see we have subtracted 10 out of 1100. So this is the same as what I have described before. Basically, you are just writing this in a short version. Num equals num minus 10. 10. So this notation up here has the same meaning as this one down below. They're exactly the same. It's just more convenient to write things this way as I have written them, as opposed to actually writing the long versions of it. Now let's go ahead and take a look at replacement or substitution. Var equals, shall say $, open up the curly brackets and type in num, and then we shall type in slash. This is not divided, this is just, we're not performing division. Here, a different form of operation is being conducted. So now we shall replace some of these numbers with a letter. Okay, so let's replace 11 with the letter B. So 11 slash B, close curly brackets, echo var right. I seem to have done something wrong. Let's take a look at what it is. So the idea is to replace something here with a letter. What it is that I'm doing wrong? Well, take a look at these numbers down below. It echoes out here, and then it echoes out here. Notice that I don't really have an 11 here. Why? Well, I have just subtracted 10 out of it. So instead of 11 here, let's go ahead and write 10. Right? And there you go. So 10 has been replaced by B. See, 10 is here and B is down below. 90 has remained the same. You can perform these very convenient substitutions during the code. For example, if you wish to convert a certain number into hexadecimal or something like that, this can be very useful. I'll just give you an example. So, all right, let's leave this to be 10. And let's go ahead and delete this part. So we would like to convert number 10 to be represented in a hexadecimal format. And if I just write this, you see A. 10 has become A. Very simple. So the hexadecimal notation of number 10 is a letter A. Hexadecimal notation of number 11 is B. Just so you know. If you wish, I would advise you to look up at number systems and within those number systems, take a look at hexadecimal and binary number systems on the net. You will find ample documentation on those things. But I would just advise you to read the definitions and to understand the basic concepts of what they actually are. So let's go into the next example. Now we will go ahead and do this. Type in let quotation var plus equals, well, we don't really need this. Type in var is equal to, I don't know, 10. And now we shall say var plus equals 1. And this will add 1 to it. But look, since var is a number now, we can say that the var shall be a letter. And we can add the number to it. So var is equal to A0. What do you suppose the result? What do you suppose the result will be? Echo out var. Let's go ahead and run the script. The result is 1. So var is now 1 because bash sets the integer value of a string to 0. So once again, bash sets the integer value of a string. This is the integer value. Sorry, not this. It sets the integer value of a string to 0. This is some sort of a string that we have here. This entire thing, A0, this is some sort of a string. This is clearly not all of this is a number. And the value of a string will be set to 1. Let me just demonstrate this. If we were to change this to 10, and if we were to type in here, hey, right? It's number 10. So the value of this up here is actually 0. These are some neat tricks that you should be aware of, as they can cause headaches later on. Okay, so let's go ahead and do the opposite of what we have just done. Not this, but the previous one where we have substituted numbers with letters. So let's go ahead and type in hey 110. I don't need to use this number. You can use any other, really. Why am I using this one? I have no idea. And now we shall echo out var. And down below, we will say, basically, oh, we don't need let. We shall say that some num equals $, curly brackets, var slash, what shall we replace? Hey. And we would like to replace hey with, I don't know, 20. Let's put it like that. Now we can go ahead and run this. And nothing has happened. What could be the problem? Let's go ahead and change this to 20 and 0. It's still the same, so there is a problem in here somewhere. Let's go ahead and try and figure it out. So var is some sort of a string. We've echoed out var, so hey 1101, that part is fine. And then down below we have typed in that num equals $, curly bracket var, which is this particular variable. And then we have stated the pattern that we are looking for. And after the pattern, we have stated what we wish to replace it by. And then we have basically just echoed it out, but we have echoed out the var. Yep. So my bad there. Right. Hey, take a look at what has happened. It's now hey 1101, and down below it's 200 1101. Could have also placed, I guess, 20 here. And you can see now it's 20 1100. These things as I said, can be a little bit tricky. Even I make mistakes, especially when I'm actually casting and coding at the same time. So I am a human being after all. And you will make mistakes, I assure you of that. Every coder does, and sometimes people get a little bit confused. That is why I have deliberately left pretty much all of my errors within the casts. I deliberately don't want to make it perfect. I do not want to give you an image of something that it actually is not. Every coder makes mistakes. It doesn't matter how good or bad you are. The people who work for the top companies out there, the coders, the developers, they make errors. Everybody does. So don't let that discourage you. It's perfectly fine. It's perfectly natural. It's a natural learning process, so to put it so. Okay, so let's go ahead and continue and use another thing. We can say that's var1, and we shall set its value to be null, so nothing pretty much. I don't really care, but hey, you can also put this. You can also declare it like this or like this. These are declarations of the same, so no worries there. And now we will state that echo var1 is equal to $var1. So what do you think will happen now? Okay, let's delete the upper parts of the code, because they might be a little bit confusing, so you won't know what is one. There's some borderline cases pretty much. So you see, again, nothing really happens. It's var1 is equal to nothing. So this will be printed out as a string, and then this will be printed out as a reference value, which is pretty much null. So nothing there. But now we shall go ahead and put something else in here, and we'll say let var, keep going to the other screen, let var1 plus equals 10, and then we shall echo out var1. You can see that var1 is now 10 in fact, but we have, because this is pretty much an empty line, we actually went into another line because we have added 10 to pretty much an empty line to nothing, and then it first prints out nothing, and then down below it actually prints out 10. Why does it print out nothing? Well, because we have echoed out nothing here first. Anyway, keep in mind that null values are not zero. Dividing some integer by a null will result in a syntax error. Null values are not zeros, but they can be treated as such in arithmetic operations. Dividing some integer by 0 will also give you a different kind of error, which is division by 0. So dividing by a null value will just give you a syntax error, while the division by 0 some integer will give you a division by 0 error, so it will be rather specific of what has occurred. So there are here we have two types of variables. So we have local, and they are variables within the code blocks and functions. They are visible outside the code block or a function. So if you write some sort of a code block or a function, they will be visible outside of it. You will be able to recycle them in the rest of your code. But environmental variables, they are created whenever the shell is started, and all child processes of the shell shall inherit these variables. So for example, if that particular shell spawns another process, that process will inherit these environmental variables. All environmental variables, they are set, and all the environmental variables that are set by the script must be exported. This can be done by using an export command. And sometimes you will need to use this in a shell when you're writing something, but not just, for example, not just in this script. You will need to use them here, for example, in the terminal. So when you start a program from the terminal, let's say I would like to start Kden Live. If I press enter, you see it's going to start it. And this Kden Live will inherit the environmental variables defined within the shell. So if something's not right, if some environmental variables are not configured to what we want them to be, we can basically pre-configure them here on the command line and then spawn a process, and then that process will inherit those particular environmental variables. We will deal a little bit more with this later on. It's not too complicated. You will see how it actually works out. For the time being, I just wanted to actually mention it so that it's somewhere out there. I will call the tutorial here, as I am running a little bit short on time, and we will continue in another one. With that, with the follow-up tutorial, we will pretty much round up this mini chapter of variables and parameters. Welcome back. So the next important subject are positional parameters, and these are actually passed from the command line. The following are the positional parameters. So this is what you see on the screen, the sort of script that I have written for you. So you can go ahead and slowly start rewriting it, but you don't actually need to rewrite the whole thing like immediately. It's a lot easier to just declare this variable up here, create the first if statement, and then copy paste this if statement down below, because they're really all the same up to number 9. You copy paste things by selecting them with your mouse and then Control-Shift-C to copy. Go into the insert mode, go down, Control-Shift-V. You see, it pastes it. This is not in Linux in general. I mean, in a text editor, something like that, with GUI, you would just press Control-C, but in terminal, you have to press Control-Shift-C and Control-Shift-V. Because Control-C is a universal interrupt. So whatever is running in the terminal, in the foreground, you just press Control-C to stop it. For example, if I start htop, and you see it's running, and if I press Control-C, it will terminate the process immediately. That's why we cannot use Control-C to copy things, but rather instead we need to use Control-Shift-C. Anyway, as I was saying, declare a variable called min, so some sort of I want to represent some sort of a minimum, just a symbolic name for it, and then create this first if loop, which we will use, and then copy paste it down below. You need to change this variable here, and you need to change this here. I don't like it that I've written first, so let's just change this. Let's just change it together. So you write the first statement, and then you type in first one is, and then $1. I'll explain what the $sign is in a moment. Second one is. Third one is. I have a bad feeling I have misspelled some of these, so I shall save myself some embarrassment and at least type them in a proper fashion. Now you see they're all the same. There is pretty much no difference. The formula, the format is the same, except for the certain things within them which you change the values, the variables. Sorry, 5th, 6th, and this one shall be 5th. There is a reason why I went to 9. It's because the arguments that you pass on the command line up to 9 are accepted are defined here in one way, and then after 9 they are defined in a different way. So I'll show you that in a moment. Let me just go ahead and fix this. 8th and 9th. My spelling is so awesome. And 10th. Okay, let's put it like that. Much better. Anyway, you write this if statement. you copy paste it up, down, up to 9, and the 10th one will be a little bit different. So you can go ahead and do that now. And while you're doing it, we can start disassembling this code and see what it all means. Notice that the script is a little bit bigger than the ones that we had before, and the scripts will at a certain point of time get like pretty big. So in this if statement, -n tests whether or not this parameter here has been specified. If it is empty, it will return false. It will return true if it is not empty. So what is this parameter? What is this $1? Well, notice how when we write the cd command, change directory command, we pass an argument to it. It goes like this, home, and then we specify some path, or we don't have to go into home, we can go into bin, and then we press enter, and then the change directory command executes, but it takes this argument into consideration. It represents something to this command, because this command would be pretty much useless without the arguments passed to it. It would do anything significant. Let's just go home. It wouldn't do anything significant without the arguments, and that is what I'm trying to teach you. So this is the first argument to the command, to the script. This is the second argument. This is the third argument, etc. And they keep on going. And we need to actually test whether they have been passed or not. And -n tests has the argument been passed or not. We have designed the script so that it needs to accept 10 arguments in order to function properly. And we go down, this is all the same. And we go down to number 10. And for if the amount of arguments that is passed to a certain script is greater than 10, then they need to be represented like this. You see? $, curly brackets, and then 10, 11, 12, 13, 14, etc. It goes on and on and on. Keep that in mind. Okay, so down below the 10th one, that is why I went to the 10th one, because at that point of time, they start becoming a little bit different. And down below, I said echo list of arguments. So this here, quotation marks, $, asterisk, will list all the arguments that we have stated above. And down below, I have stated echo name of the script. Now we would like to output the name of the script. $0 represents the name of the script. Can anybody tell me what the name of the script is? Just think about it for a moment. I will show you rather fast. Now I have an escape character, and then the quotation mark again, $0. I've told you what the $0 represents. Quotation mark, escape symbol, quotation mark, quotation mark. Now, what I would like you to do is to take this line into consideration and try to imagine and visualize what it is that will be printed out onto the screen. Why have I placed it so? Because I really need only these two quotation marks and $0, and I need the last one to close the first one. But why do I have these two extra quotation marks here with escape chars? And down below, this symbol here, it will, in essence, represent the, it will check if the number of arguments passed is, well, the entire statement will check if the number of arguments passed is less than 10, but the $ hash is the total number of passed arguments. So this will represents the total number of passed arguments, then you have lesser than, and then you have our min variable, which is 10. So if this is true, if it's less than the minimum amount of arguments that we have specified, we will echo out not enough arguments, need 10 to run. I know I have such innovative way of writing, the simplest, purest form of writing. I mean, basically like a hammer on the nail, even though I cannot relate this analogy to this situation, but I just felt like saying it. Anyway, So hopefully now you understand the entirety of the script and what it does. Now let me show you how is it that it is ran. So we do ./first, and now we're going to pass a list of arguments. These arguments can be pretty much anything. I will type O. I'll just start from left to right. So it's going to be Q, W, E, R, T, Z, U, I, O. I think this should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And here you go. So first one is Q, second one is W, third one is E, etc. And it goes on all the way down to 10. And now we have a list of arguments which is printed into one line, so we can see what arguments we actually passed. And then it says name of the script, and it's printed out in quotation marks. That is why I have the escape characters here and here, along with the extra quote marks, so that the quote marks would actually be printed out here when I output the name of this particular script. So simple as that, no big deal. Hopefully you can understand without bigger difficulties. And I shall see you all in the next tutorial, hopefully. Welcome back all. Today I will talk about return values. So, when writing a script, it is important to know if the script executed successfully or not. Why is this important? Well, aside from the obvious reasons, sometimes you will run a script and you will not know whether it executed properly or not unless you are familiar with return values. One of the most confusing things for beginners in Linux tends to be the return value of 0. So when you run a command and nothing happens, that is usually a good thing in Linux when there's no feedback. I know, right? Strange. Here, let me just give you a small example. You will need to switch your user to root. Just type in SU, press enter, and then type in the password. I already have a terminal opened here, so I just decided to drag it from another screen. And if I, for example, use this command to basically set the status of a certain service, so if I type in system ctl status, or let's just type in restart httpd dot service. What? Nothing happened. I just issued a command to restart my web server and I didn't get any output. Like, what is wrong with this? What is missing with this picture? What is missing in this picture? Well, nothing. Everything went fine. Everything is perfect. That is the return value of 0. If you run it, if nothing happens down below, fantastic, the command ran. I will demonstrate this further. But for example, if you something, you see, if I attempt to restart a non-existent service, it says fail to restart something.service, unit something.service failed to load no such file or directory. It's going to issue out an error message, and this is also a return value. So in Bash, we have we will revisit this, so do not worry. I just want to give you a quick demo of what it means to return a 0. And why is that a good thing, and why anything but 0 is generally a bad thing, and the fact that it's a little bit difficult to get used to zero feedback from the system. Like, for example, when I restart my web server, the return value is 0, everything went fine, but if I didn't know that, I would have no way. I would have a way of knowing it, of course, but just by looking at the screen, I wouldn't know really, did my command ran or not, what happened, etc. So anyway, in Bash, we have an exit command that is in charge of terminating script execution and giving us the status of the script execution. So the status is available to the script's parent's process. For example, this terminal, if I run a script from it, this is the exit status will be available in this terminal, just like to the systemctl. Just like when I ran systemctl, the exit status was printed out here on the terminal. This is also another exit status. It's an error, it failed to load. And just keep in mind that even if the script doesn't have exit command, exit status is returned. And in that case, it holds the status of the last executed command in the script. Very important to keep in mind. The exit command, I will demonstrate it of course, but let me just give you a little bit of dry talk and then we'll go immediately into examples. Exit command can be done, can be with and without parameters. But usually, the parameter that is given to the exit command is $? So this, $? What is this? Well, $? holds the exit status of the last command that was executed in a function, which is equivalent to the return values in other programming languages. I'm guessing that you're not coming from some sort of a heavy programming background, so you're not that familiar with this, but the case is pretty much similar across the board in pretty much all the programming languages out there. Functions, which we will deal with later on, they all have some sort of return values unless it's a void function which doesn't have a return value, etc. So the return value can be a lot of things. It can be a string, it can be an integer, it can be a single character, it can be I don't know, just as many variables as there are. Pretty much that is how many types of return values you can have. Anyway, let's go ahead and take a look at the example and see what this actually means. Let's just open up, oops, I'm not gonna do it in the root terminal, no need to do that. By the way, these scripts that we are writing, unless I designate it so, please don't run them as root, there is no need for it. I'm guessing that you won't do it, but even if you do it, in general, you won't really cause that much harm anyway. But just stick to the safe side and use it as a regular user, and you should be fine either way, but it's much better to run it as a regular user. Anyway, so let's go ahead and type in vim first.sh, and as you can see, I am a regular user. It says chronic at my domain. My domain is the host name of this machine. So let's go ahead and type in echo and type in tralalala. Excellent. Down below, we shall type in echo again, $? So what do you think that this is going to output? Just think about it. Why did I quit? I have no idea. It says tra-la-la-la, everything went fine, and then the return is 0. That's good, no problems. But if I go ahead and type something in, just smash my keyboard like this, well, just smash my keyboard in terms of letters, because I don't feel like doing this 100 times. If I run it, what do we have here? It says /first.sh line 5 trala something command not found. Exit code 127. Now, since this is not a command, and since exit status is not 0, but some other integer value indicating that the last command was not successful for whatever reason, 127 is the value of the exit status. It can be traced to a particular error, as pretty much all the error codes are listed, are well documented, and you can find them without much problems either on the net. You basically type in bash error code 127 or bash error code, etc., and you should be able to find it without any problems. But here you can really see what it says. I mean, it's literally telling you what the problem is, so you don't have to actually go and look for the error code or anything like that. You can also find them in Linux as well. it says that the command was not found. It doesn't recognize this particular command. And this is why $? Is very useful when it comes to testing commands in a script for whatever reasons. I mean, if you run a command and you wish to know whether it works or not, well, you just put $? Below it and run the program once. Have a look. If it throws out an error code, you'll be able to figure out based on that error code what the problem is, because you will also get a message as well. So you don't have to be that concerned about it. But it's very nice that you can actually print yourself an error code, and then when you go onto the forums or something like that, hey, you can say, I got this error code, this is the problem, could you help me out? Here's my script and here's my error code, and I get the error code on this line for this command. And obviously then people will be far more forthcoming, as opposed to you just pasting a script somewhere on the forum and stating, hey, I have a problem here, it doesn't work. The next post below you will be, can you give us something more? Can you explain something more? Usually what people will ask immediately, what sort of an error did you get? What was the problem? But when you put it like this, somebody was able to help you out immediately, as opposed to somebody posting and then you posting after them, and then they posting back again, asking you more questions, etc. Anyway, let's go ahead and continue with our script. So let's define a couple of variables. Let's first delete this and type in no, so number of, sure, why not? Number of args equals 2. And this will be the number of arguments needed. The next thing that we want to do is define our exit status. So if incorrect number of arguments is passed, we should have this. So E underline, how shall we name this? I don't know, bad args. Bad args, I guess, is fine. 85, and E underline. So this will be, for example, we shall have this error code if we are unable to read we shall have this exit status if the program is actually unable to read a certain file. Let's put it like that. So I'm a wonderful speller. Unreadable. Thank you very much. So 86. And let's go ahead and start typing. So if, make sure to place a space here, bracket, and we shall have a $hash dash any space quotation marks, and then we shall reference a variable args. Excellent. So let's just go ahead and type in then. Fantastic. So what this means in this, what this condition represents, it basically states if the number of command line arguments is not equal. So the number of command line arguments, I'm selecting it. So this has that meaning. The symbol $sign hash. If the number of command line arguments is not equal, so NE, not equal, and then we're referencing this variable, so we get the value is not equal to the number of args that we have specified, we want something to happen. So let's go ahead and jump into that. Then echo, and we shall type in usage. And we need, oops, yep, there we go, reverse quote marks, base name, space $0, reverse quote marks, I don't know, let's type in test file 1, test file 2. And let's type in the exit. I'll explain in a moment. Let me just type it in. It's a little bit easier like that since it's a bit more complex script. It's not really complex, but bad args. I don't want to really miss anything here. Bad args, and we're gonna finish it. We shall finish the if statement. Anyway, so now that we have defined the condition, the base name will basically print out $0. What is a $0? Here, do you remember from the previous lessons? It is the name of the script. It is the name of this script that we are writing now. This is used for usage messages. If the script was called, but not all required arguments were passed to the script. So we would like the exit status. The exit status will be 85 as we have defined it. So we have 85 here. It says bad args, and the exit status will print that out if this condition is not satisfied. So if we don't pass exactly 2 arguments, then we're going to have a problem on our hands. That way you can actually make it mandatory for users to pass a certain amount of arguments or a certain range of arguments to a script, which is also a common practice with Linux commands. Some of the commands, when you run them, they have mandatory positions. They have mandatory arguments which you need to specify. And if you don't specify them, it throws you an error message and it opens up a help menu which gives you a syntax and a list of arguments which you can pass in order to help you out. So now that we have finished this loop, we are going to continue on writing this beautiful script of ours, which is going to go on for a bit longer, and then we're going to run it, and we shall see. As I said, the scripts will progressively get more and more complex, and we will get to the point of time where we will have a pretty big script, so I might just open it up for you and not type it in like this, not to waste time. Anyway, let's go ahead and type in if, bracket, bracket, exclamation mark, dash R, quotation marks, $1, close quotation marks, or exclamation mark, R, $2, and let's go ahead and close this. Then it should be fine if I didn't mess anything up here. Okay, it should be fine. Anyway, dash R will return true if the file exits and it is readable. So dash R will return true if the file exits and is readable. The exclamation mark is logical not, as I have explained before. It reverses the test result. So if either of these files does not exist or is not readable, we will define the exit status down below, which will be 86 as we have defined it up here. But the coloration seems to be a little bit off here, and I'm thinking of what it is that I wrote wrong here, but I can't really see anything. It's probably something stupid that I have overlooked while typing. But well, let's have a look and let's troubleshoot it in a moment. So if we type in then, we shall type in echo files are real. Let's put it like that. I was thinking of writing files are in existence or they are readable or something meaningful like that, but let's go ahead and type in files are real. Exit, and let's go ahead and reference our exit and reference E underline unreadable. There we go. So with that, we can finish our loop. Now let's go ahead and run this and see what happens. Are we going to get any error messages? Is it going to be fine? And of course, we have a problem. So line 17, what is EOF? What does that mean? It means end of file. Very important marcation, which we will be utilizing at later points of time. And then we have an unexpected end of file. So there is a problem somewhere within this script, but I would solve it now, but I'm literally at 19 minutes and 30 seconds. So I'm running out of time. The videos need to be 20 minutes each, and we'll get into troubleshooting in the follow-up tutorial. I do believe that the troubleshooting part is actually useful for you, and that is why I always leave it in the videos. Welcome back. So by now I imagine that you have managed to figure out what the error is, but here's what I was looking at. First of all, hey, look at the error message. It says while unexpected end of file while looking for a closing quotation marks, for matching quotation marks. It places here for matching, but when it says for matching, there is one and then it needs the other. So I guess the other one should be the closing one. Anyway, if you take a look from the top to the bottom, you will see that the code below is not highlighted properly. And you will see that the exit command is not highlighted properly immediately. So I take a look from there. So I started looking from there. It says echo, quotation mark, usage, base name, test file, test file. Okay. Here's the error. Look what happens to the coloration, to the colors on the screen. Look at how text changes colors. Look at how the highlighting is different. Voila, there you go. I missed the quotation marks. But no big deal. Quite a common error. And then you start looking around and trying to figure out what it is that you did wrong, and believe it or not, like in C or something like that, people sometimes waste an hour because they made some sort of a trivial mistake somewhere in 10 billion, well, not in 10 billion lines of code, but let's say in a million lines of code. Spend a long time looking for the error, even though you have a large amount of debugging tools which help you a great deal. Anyway, in Bash, you get the error messages, and they tell you have the error messages, you have the exit codes, and they help you troubleshoot your code and see where the problem is. Debug it, basically. When you don't actually troubleshoot the code, you debug the code. You take the bugs out. An old statement which dates back to when they actually first started using computers. It does have something to do with bugs, like real bugs. I advise you to look it up on the net. You'll find the definition quite curious. Quite interesting. Anyway, let's go ahead and continue. Now, first of all, in the previous tutorial, we have used this funny looking thing and this funny looking thing, and we have stated that the R will return true if the file exists and is readable. We know from before that the exclamation mark is the logical not, so it reverses the test result, so it goes into reverse. If either of these files does not exist or is not readable, well, then it's just gonna go ahead and echo out that the files are real, which is very stupid of me to have written it. So I also made an error there. I should have probably typed it in like this, which would make more sense. Files are not real. There we go. So if either of these statements, if either of these files does not exist or is not readable at all, then echo out files are not real. Files are not real. I wrote files are real for some strange reason in the previous tutorial. I don't know. And down below it says exit, and then we shall have a reference variable where we will get the exit code of 86. So we will know what is going on. Let's go down below and continue on typing. We will use the CMP command next, and CMP command stands for compare two files 1 byte at a time. When it encounters the first byte in one file that is different from the other byte in the next file, it's going to say this byte and this byte do not match, and it's going to exit. So what do we want to do there? Well, let's go ahead and use the first argument, and let's go ahead and use the second argument, and let's go ahead and do the redirect. This is a short version of redirecting both the error message, so the standard error, and the standard output, what is the output, into something, into a file. And our file today will be dev null. Very important place. Arguably the most important place. Let's put it like that. No, just kidding. Dev null is basically a black hole in Linux Unix world, where you basically, whatever you put in it, it goes to nowhere. So whatever you put into this file, it goes to nowhere. For example, what people tend to do when they are angry at their ISP providers is something like that. They tend to they tend to use a lot of bandwidth. How do they do that? Well, they just find the file on the net and they keep downloading it on end. They start downloading a lot of files and they max out the bandwidth, and they redirect all the output to go into dev null. So it's going to nowhere. It's not taking up any disk space. It's not taking up your disk space. It's fine. It's just going nowhere, but it's still being downloaded. Amazing, I know, right? So if this is going to compare the two files, basically what we're going to do here is that the CMP does return a 0 indeed if the files are identical. So the return value is 0 if they are identical, and it will return 1 if they differ. So 1 and 2, $1 and 2, they're the parameters or the arguments, the names of the two files in this particular case, and the ampersand sign greater than, that is the redirection operator. As I stated, it will redirect the standard error and the standard output of the CMP command to basically nowhere, to /dev/null. Writing to it has no effect of whatsoever. Let's go ahead and continue coding. Down below, let's go ahead and type in if bracket $question mark. Hopefully by now you remember what this is. EQ 0 bracket. If the exit status is 0, basically this represents the exit status, and if it is equal to 0, then we would like to state, because remember, the exit status of the last command run is taken into consideration, and this will be the last command that we will run in this program. Well, not the last program, but it's not the last command that we will run in this program, but it is the next to last command, because afterwards we have this if statement and we have the exit status. So if this runs out successfully, the exit status at this point of time will be 0. If it runs unsuccessfully, the exit at this point of time will be 1. Whatever we write down below, for example, if we were to write an echo command down below or something like that, then that echo command would again alter the exit status depending on whether it is successful or not. But now this command will set and define the exit status, assuming that everything up to that point goes well and the way it is supposed to. And now we have an if statement, and we shall type in then, and then echo files are the same, else echo files are not the same. Fantastic. Fi, finish, exit 0. So, if everything goes fine and dandy up to this point of time, this command will run, it will compare the two files, it will redirect its output to dev null. Why? Because we don't really want it on the screen, okay? We don't care for the output of CMP at the moment. That is why we are redirecting the entire output of the CMP, whether it be an error message or not, whether it runs successfully or not, whatever. We don't want it to output anything to the screen. We just want it to we want to redirect that output into dev. Now, if you want to actually run the CMP in the terminal, just find any two random files and type in CMP file1, file2, press enter, and see what the output is. Have to be in the same folder, or at least give a path to the file to each file. Then down below, since the exit status will depend upon the CMP command, as that is the last one that is run before the condition is set for the exit status, we will use the exit status to basically make the output on the screen dependent on it. We will say if it is equal to 0, so if this command returns 0, then the files are the same, because this file returns the value of 0 if the files are the same. If they are not the same, if it is not equal to 0, whatever else it is, it's going to be 1, but whatever else it is, please echo files are not the same. And once you're done with that, just go ahead and exit with 0, stating that this entire code went well, fine, and that all is well. Let's go ahead and type it right. Let's go ahead and type in first.sh, and let's try not passing any arguments. It's going to give us usage. Okay, fine. And let's go ahead and type in, what do we got here? Got blah.txt, and we got tralala.txt, and we got wood.txt, and we have whatever.txt. Wow, I have truly creative names. Let's utilize some of them. Blah seems to be the easiest one. The next one should be wood. Files are not the same, obviously. Okay, let's try to compare two same files. Files are the same. Let's try to pass just a single argument. No, it's going to give us usage. Let's try to pass non-existent files. ggggg.txt. It doesn't need to be txt, just ggggg. Actually, let's just do this. Simpler. So this is going to be my awesome file name. Files are not real. One of the conditions that is missing here is that we should state which one of these files is actually an illegal option here because it is not readable or it doesn't exist. But okay, we can do something similar in the follow-up tutorials. At some point of time, we will go through this. Basically, it says that they are not real, but it states that both of them are not real. Actually, you know what? You should try to do that yourselves. Basically, just try to alter a piece of code in the script. Should know which part you need to alter, and make it so that it actually states which one of these two files is not real. So which one doesn't exist, which one is not readable, which one cannot be accessed. If you have any difficulties, something like that, well, there is always the discussion section. I won't go through this in the follow-up chapter. You should be able to do this yourselves. If not, it's okay. Don't worry about it. There is the discussion section. I'll be more than happy to help you out, or somebody else who will be in charge of tech support at that point of time will be there to assist you in any way possible, pretty much. But I would encourage you to give it a shot. One more thing that I forgot to mention, actually just a couple of them. Keep in mind that the logical not actually reverses the result of a test command or command which affects the exit status as well. So this is a reverse in this case. Although this part, I assume that some of you might have not understood it quite well, or that it might remain problematic. So again, feel free. Hey, there's the discussion section. Just pose a question. Somebody will be there to answer you and to write an explanation down for you. Glad of will. Happy to do it. And another thing that we need to be aware of that should be kept in mind at all times is that the exit status can be user defined. However, some of them have special meaning and should not be tampered with. Return values, they are important in terms of debugging, as I stated before during the script, but here's a bit of a summary. If the script failed executing or something like that happened, then you need to take a look at these return values and you need to take a look at what is going on. You need to take a look at the error messages. The return value of our script, if it is a non-zero, it will help us understand where the problem lies and thus enable us to solve the problem in an easier fashion, to actually be able to localize our problem as opposed to looking at the whole script and wondering where the problem might be. Sure, it looks simple because the script is small to take a look at the whole script now, but imagine that you have around maybe 500 lines of code. What? You're gonna scroll down through 500 lines of code to figure out where the error is? Of course not. You will have some sort of exit statuses, and you will have return values, and you will have error messages, and it will tell you on which line the problem lies, etc. So you will be able to localize it and then figure out where the problem is. Solve it in a far quicker manner as opposed to just looking at the whole script. So anyway, once again, if this part remains unclear, please feel free to post in the discussion section so that I can help you out additionally. That is why it is there, for me to be able to communicate with you and for you to be able to communicate with each other. But don't worry about it, you will get support if you ask for it. I bid you farewell. We shall see each other hopefully in the follow-up tutorial. Welcome back. Today I'm going to go ahead and talk a little bit about conditions. So no big deal. We have already done the conditional statements before. We have seen how they function in examples plenty of times before, but there are a few cases which I have not shown you up to this point of time. So let's go ahead and take a look at a few examples. Not going to burden you too much. Let's define a variable called num, and let's say that variable's value, let's assign a value